to the inauguration of Nodal Center and live demonstration of virtual labs. I'm extremely elated to share the information that SRM IST Ramapuram has been recognized as a nodal center for establishment of virtual labs by National Institute of Technology, Surathkal. We have added another feather in our cap, and there are many more in the pipeline. With these few words, let me welcome you all once again. At this momentous juncture, I invite Dr. G. Prabhakaran sir, our Vice Principal Academics, to present the welcome address. Sir?
Okay. Can you hear me?
Yes, sir. We can hear you, sir.
Yes, sir. It is very good morning to all. It's a great pleasure to be a part of this, playing a role of welcoming all. Uh, First of all, we are all gathered here for the inaugural function of establishing this SRM IST Ramapuram campus as a nodal center for virtual laboratory initiative by MHRD with NIT Surathkal. So, respected chairman, respected co-chairman, and respected director, and respected dean, VP admins, VP admin, and HODs, professors, and my dear faculty members, and the team from NIT Surathkal expert team, Dr. Gangadharan, Ms. Aishwarya Hegde, Mr. Beryl Thomas, Mr. Rohit, and Shrestha. Indeed, it's great pleasure for me to welcome you all for this, the inaugural function. Of course, this is order of the day that despite this pandemic situation, we are well connected through virtual mode, especially conducting laboratory courses, which is a challenge for every one of us being in education sector. Of course, this is a greater opportunity. It will help us to arouse curiosity among the students and also the faculty members. It helps us a lot in remote learning, and this virtual laboratory initiative will definitely help us to get connected with costly equipments which everyone cannot able to afford in large numbers. So we can have access through this. These are the major benefits with the objective to inculcate culture, such a culture in our campus to improve upon so that it is effectively put in force to benefit the student committee. So with this, once again, I welcome all the dignitaries who are gathered here and gracing this occasion by their presence. Once again, I welcome you all. Thank you very much, sir.
Thank you, sir, for your warm words of welcome. Our director has always been very supportive of all our ventures. I thank and invite our respected director, Dr. V. Subbiah Bharati, sir, to present the presidential address.
Very good morning to all of you. At the outset, on behalf of management of SRM IST Ramapuram, we express our gratitude to Dr. K.V. Gangadharan, Chief Guest today from NIT Surathkal, for having extended this facility to SRM IST Ramapuram campus. Professor, it is a very challenging time for both of our states, Karnataka and Tamil Nadu. We are struggling, but however, I am very hopeful that, like the corona wave one, this also will pass and will come out of this temporary phenomena. But it is a very challenging time. But however, even during this peak of pandemic, the academic community, we are sitting together today, inaugurating a virtual lab. So that shows our involvement in adapting to new situations. One of the positive points this pandemic has brought in is virtual mode. It is a long due. For many years, the academic community, they were talking about this online and virtual mode, but there was a resistance even from our side. But slowly the people understood, and this is going to be the order of day in the future. And this will immensely help the students to hone their skills. For the kind information of our chief guest today, sir, in SRM IST, we have virtual lab in practice now. So we have a centralized server in the main campus, which will cater to about 25,000 students spread across 4 campuses in India. This mission was started 5 years back, virtual lab, but it was limited to only few laboratories, mostly concerned with computer science. So we are in expanding mode, but however, we feel very proud to collaborate with the NIT Surathkal in this mission because the quality of the virtual lab going to be provided by you will definitely help our students to improve their skills. So in the coming days, I expect the teaching community of SRM IST Ramapuram to utilize this opportunity for the benefit of the students. Once again, I congratulate Dr. Prabhakaran who has taken initiative in implementing this, and Dean and his team for taking forward. Today we are inaugurating this program. Once again, I wish you all and our gratitude to Dr. K.V. Gangadharan and NIT Surat. Thank you, sir. Thank you.
Thank you, sir, for your warm words of motivation. The motivation and immense moral support given by a most respected Dean Sir of Engineering and Technology has enabled us to complete many tasks and achievements with ease. I thank you, sir, and invite you to give the special address.
Sir, very good morning to everybody present here in this today's online session, and the eminent personality and chief guest, Dr. K.V. Gangadharan sir, who is head Center for System Design and Professor in Mechanical Engineering, NIT Surathkal, and our beloved director, Dr. V. Subbai Bharti sir, and the vice principal, and the person who is behind this this virtual lab, Dr. Prabhakaran sir, VP Academics, and VP Admin, Dr. Jagdishan sir, and the head of the departments, faculty members, those are here in this today's session. A very good morning to everybody present here. I'm very happy, sir. Actually, as per the director sir said, the virtual concept has come into the picture for the past I can say that past 1 year, 2 months. So thanks to the technology, in fact, this is a very great initiative has taken by this the Ministry of Education under the National Mission on Education through ICT. Along with this one, there are pioneer institutions are there like IITs and other things. Along with this, I find a very good competitor is NIT Surathkal. I find only one NIT among all the IITs. We felt very happy, sir. Your contribution from your institution to enormous, and the concept is a very interesting, sir. And nowadays, exactly what the student is required, this one only. So now, to provide a remote access to the labs in various disciplines, like whatever you take, either core, EEE, CSE, mechanical, CSE. Then these virtual labs would cater to students at the UG level, PG level, as well as research scholars. And also another important one is nowadays the sources are very expensive, sir. When you want to establish any system, the initial investment is very high when you see on the software side. So the greatest advantage here it is to share the costly equipment and resources. So through this, what I said actually through this remote, even we can share this one equipment and resources in a multiple manner. Even it is available in a limited number of users due to constraints on the time and as well as the distance, etc. And I am very happy, sir. And in fact, I am also very much interested in this today's session. I will also be joining, particularly for the core departments like mechanical, civil, and EC. And I am very happy, sir, in spite of your busy schedule, you have been offering here today. And we are sure that in future also we have to conduct many more programs like this through this virtual lab concepts. Thank you, one and all, sir, for giving this opportunity. Thank you, sir. Thank you very much.
Thank you, sir. Now it's time for the most awaited address by the resource person. I present before you the resource person of the day, Dr. K.V. Gangadharan, sir, participating institute coordinator, virtual labs, professor and head, Center for System Design, National Institute of Technology, Surathkal. Dr. K.V. Gangadharan is professor in mechanical engineering and head of the Center for System Design, President, Institute Innovation Council, National Institute of Technology, Karnataka, Surathkal. He has earned his PhD from IIT Madras in the year of 2001 in the area of railroad vehicle dynamics, ME from NIT Trichy in the year of 1992, BTech in mechanical engineering from Calicut University in the year of 1989. His areas of research are system design, vibration and its control, smart material and its applications, structural health monitoring, and product design. He is also actively engaged in creating learning materials for experiential learning of basic components in engineering. He has teaching and research experience of 27 years and industrial experience of 1 year. He is actively engaged in industrial consultancy and sponsored research projects and has more than 120 research publications to his credit. He has filed 7 patents, 4 in the area of medical devices and 3 in smart material application. An active HAM with a call sign of VU2TAO in charge of amateur radio facility at NITK Surathkal. I place on record our indebtedness to Dr. K.V. Gangadharan sir for sparing his valuable time, and I request sir to address the gathering. Now, I hand over the session to Dr. K.V. Gangadharan sir. Sir, please.
Yeah, very pleasant good morning. Hope I am audible.
Yes, sir, audible, sir.
So I also need share. Share is given to me now. Good, thank you. Very pleasant good morning on behalf of NITK Surathkal. It's a privilege to be partnering with a well-running, well-developed SRM University and its Ramapuram campus. Thank you, Dr. Prabhakar, who took the initiative, but thanks are due to all the administration, starting from director, dean, and all the vice president, vice principals, and principal, who have taken it forward, say that yes, we are willing to experiment. And this is a time for all of us to experiment. Without any undue delay, let me just put my screen up. I hope you are able to see my screen.
Yes, sir, the slide is visible.
Oh, thank you. So, as I said, welcome on behalf of National Institute of Technology, Karnataka, Surathkal. I know I cannot invite you to my institute now, so please visit our v2.nitk.ac.in to get a glimpse about our institute. We hope we will be one day a carbon neutral institute with sufficient power being generated from the solar and wind, etc. And hope we will create minimum waste. So today we are looking at tools for experiential learning in this online era, online time. So we are looking at, is there a possibility without having difficulty and trouble to the faculty, can we make the concept much more experiential? So here we are saying the faculty need not have to take the pain of creating it. Someone has created it and made it available to them, and how to use these tools for providing experiential learning. So I'm sure that you remember how did we think about years, BC, AD, all that we know. Now we are in 2021. But presently, we keep looking at the time period like this before COVID, and hope during COVID is a small period, and then the bright after COVID period. So we all hope and wish that after COVID period comes quite fast. But whatever be the difficulty, we have been doing our work, whatever limitations we had in resources, but still we wanted to make sure that our learners are getting enriched with whatever way we could give input. Now the question is there an opportunity for enhancing the way in which we do the online teaching and learning making it more experiential? So I'll set a condition, how do we get into that and create a situation, then tell or explain the concept of virtual lab. So I'm sure all of us are here and we have taken off. We have taken off during this COVID saying that, yes, we are teachers. We are going to impart information to our learners in such a way that as they got it from the physical classes, we'll still struggle and put our effort to make sure they get what we are providing. So let us just look at, did we change as such? I'm sure that you recognize this. We have been changing from ape to the modern day ape. It looks very similar. Thanks, it is an unclothed human being, but fortunately it is a man. And look at the shape in the beginning and the shape now. So we have been changing. Our systems have been changing, both transportation, communication. Some of these pictures may be only archives for our younger generation. If you show them something in 1930 television and ask them what it is, I'm sure that they will not be even able to identify. So things have changed a lot. From the brick phone, which if it falls on the tile breaks, and the new Apple phone, if it falls, our heart breaks because of the money. And we also know 1G, 2G, and 3G, and all Gs. Other than the gravity, we are also having some fun with 2G because of reasons which we are all aware. And things have changed, has evolved. Computing has evolved. And I would like to take your attention to some basic physics in the next picture, which I am going to disclose. Look at the evolution of man and computer. I'm sure that you are able to recognize conservation of mass there. The bigger device and the thinner man, and the fat man and the thinner device. So mass is getting conserved. And we have been evolving from there. We have connected device, body area network, all that has improved our life, hopefully. From there, we again started looking at, are we going backward? It is left you to put the arrow mark from F to ape or ape to F. We have been thinking that more than our younger generation have been thinking that their entire universe or the cosmos in the 5-inch screen. And we were not very happy with that in the beginning. Now we are forcing them to be there on the screen because we need them to listen to the online activities which we provide. And our signboards have changed. We have both reality and virtual reality and augmented reality. There are options, but due to hardware limitations, many of us may not be able to implement it in for a wide spectrum like the group of students we have in India. Did we change our classroom as such? Just look at the picture. Look at the way in which we have been conducting exam 2016 and 1916. Believe me, the color, it was only the black and white photography which was available then. Otherwise, we did not change much. And we have been making sure that our students are keeping quiet by our force. And we were so good in this. Irrespective of the kind of creature come to our class, we conduct a uniform examination to make sure that we do justice. That's a claim which we do, whether it is a flying one or a crawling one or a swimming one. We tell them to climb the tree. If they climb the tree to the top branch, they are passed. Otherwise, we keep ridiculing them, saying that if you cannot climb the tree, you are not getting into. And many a times, the creature in front of us may be very differently abled in different ways, but we test them in one. So is there a way we can think slightly different and provide situations and creative opportunity for the students to make sure they blossom? So I'll take one or two cases of an unstructured problem statement to say why we need to think about experiential learning before I introduce experiential learning itself. Probably I'll take one condition like this. So A student came to my room and I had given him some time to talk to me, maybe for a project activity. But he saw that I am so much in uh, in a situation that I am not able to give him time. So he asked me, "What is bothering you, sir?" And I said, "My office table is messy. This is a kind of table I have, and I am searching for a very important paper. I don't think I will be able to give you time now. Please come afterwards." Assume that the same boy goes back to the hostel and gives this as a problem statement. And his classmate or the roommate asks, he is trying to find a solution for that. I'm just asking, is that kind of an environment we are able to create? Okay, a student came to my room so that I'm not able to give him time because I was searching for something on my table, and he goes back and tells this in his hostel room. And the bright student sitting in the hostel is trying to find out an opportunity there. So he asked more and more questions to the student who came to my room. He asked, "What are there on the professor's table?" Said there was an old computer, an old scanner and a new scanner, and grandfather's telephone. Remember, we are in a government institute, we can't throw items that easily. So we also have a new items coming in because I had projects. So I had many things which was purchased and a lot of data and a heap of papers. So he just mentioned these are the things. Now, think about a situation as a random statement like this. Professor could not give me time because his table was messy. Converting that into a product or a product idea. Are we making our students to think in those directions? And we teach them so many things. Are they able to use them when it is required? So I'll just give it like this. My office table is messy. Help me. Now, assume that the final product, I'm cutting short the discussion. Assume that the student has come out with a final product like this. Look at this. If you can imagine what was there on my table, all the mess probably could be just removed, and this is enough. And probably this product might have come from such a random statement, an unstructured problem statement. All the documents are on the cloud. I have one device which does everything for me, a multifunction device, and I have an equipment, a computing device which has no wire entanglement. Look at the way in which my table is messy to come to a product. Are we getting our students to think in this direction? What is missing? We have been giving them information, but they are not experiencing that and able to use it when it is just required. I wish my office is like this. Of course, not. So that is one from the higher end perspective. Let us take something which is much more down to earth so that we will be able to recognize it is not necessary that we should always look at high-end technology domain to look at an unstructured problem statement. I'm taking something like this now. Assume that your first semester students, when they come, you give these pictures and ask them to help. And I'm looking at only up to 12th standard physics, which they have studied. Are they able to apply what they have studied, convert that into a solution rather than remembering the equation and reproducing the solution for a standard question which we provide in an exam? So let us look at the solution now for this, and then we will look at physics involved in that. So please carefully watch the picture there. And I would also like you to type in the chat box. I have a computer next to me. I'm just looking at the chat. If I'm turning to one side, it is I'm looking at the another system next to me. So I would like the participants to look at these pictures and see what do they see. How did that heavy mass, the pain of the mass is reduced in these three pictures. So if I can just mark the pictures like this, I'm marking it as 1, 2, and 3. So I would like the participants to look at this and give me 3 basic physics principles which has been used in order to reduce the pain of this load. So your time starts now. I would like you to be in computation mode, wherein all of you type in what you find in figure 1, figure 2, and figure 3. What is the basic physics which is used in order to reduce the pain of carrying the load. Your time starts now. Please go ahead, sir. Remember, we are on an online mode. The only way I can know whether my participants are with me or not is only when you respond to my questions. I hope participants can.
With you, Professor. We are listening. We are attentive. We are with you.
Okay. No, because only way I can. I hope the participants can do chat.
Yeah.
Yeah, because if someone can just type in chat, I am seeing Srinivasan has written 3. No, I am looking at, okay, we'll take picture 1. What is that they did in the picture 1 in order to reduce the pain of carrying the load? 3 is the best, okay, Raja says. But I'm looking at what is the basic physics behind helping people in creating this. I think some of you have your video, mic on. So if you look at, I think multiple people are saying depend on the application. No, I'm not talking about which is the best solution. What is the basic physics used? Because it is the same load being carried, but what is the basic physics used in order to reduce the pain? Okay, reduce the liver mechanism, good. Force constant pain. Load was lifted on head. Load will be eventually applied to other area. Okay. Now look at the first picture. If you're able to identify this area where I have just drawn a diagram in a circle, you see it is an application of F by A. The total force which is coming is applied on a larger area. So what we did is the equation which we have been teaching to our students as F by A is being used. Host can mute other participants. Host, kindly mute other participants. Thank you. So when F by A is applied, if the student had experienced the concept of F by A, then he or she should be able to create such solutions. The second one is to do with, if you look at this, it is to do with center of gravity. If the load is applied at a far distance from CG, a small tilt can create moment, force into distance. Okay, now we are moving the load towards the CG, hence even if you bend or if you have a displacement, that is not going to be much affected. Obviously, along with that, the lot of area for the force to be acting on is also being used. Second one is, why should I carry? I can roll. The rolling friction is much easier to be handled than you need to carry all the time. So this is one way of looking at things. So this is what I was asking you to do. And this is from Vikram Thirubai. It was his third semester assignment in NID Ahmedabad. Now just look at another situation. And I want you to think about solutions. Okay, then this will reveal us, okay, we have been teaching, but we never made them experience the concept. I'll just give you the solution directly rather than taking time on chat. You look at this solution, wheels, well on wheels. This one possible solution, we know it can be, there are multiple solutions. So if our students are able to find out solutions like this from a standard problem statement, then they have experienced the concept. Okay. Now, from the unstructured problem statement, I'll come to your classroom. Assume that an electronics and communication faculty was asked by a few students, sir, we have an idea. We want to make the wiper smart. Okay, that is the idea. But remember, they are from electronics and communication. The faculty really want to help them, and they want he want them to make sure the concept which they have about a wiper need to be implemented, but he finds a difficulty. So it has to be done with automobile, whereas they are from ENC department. And for him, cars probably are connected. They have a lot of communication, data acquisition, and quite a bit of software. Whereas earlier car was looking like this with 90% of mechanical components. Now it has almost come to, I think it is 60% electronic sensors, the software, and 40% mechanical. And what we have in that is from every domain. So that means it's a perfect example for a multidisciplinary or even transdisciplinary work, the automobile or the connected car. So from here, our faculty want to help the student who came with an idea about a smart wiper. Let us see how the smart faculty is guiding the students. So he understands this is what is required. This is the existing system, and the faculty wants the students to understand how this is operating and also want to make sure that their solutions are implemented on an existing system, but much more effectively. Now, then he needs the students to go through how the wiper is working. So he brings down, and he was thinking that if he had an opportunity to tell them what is that third semester mechanical students study in kinematics of machine or theory of machine or mechanics of machine, and they cannot attend one full course, but there is some provision to get this basic understanding. Hopefully they will do a better job on doing a smart wiper. So let us see how it is done. So if you go and ask a mechanical faculty or a student, they will tell you how this is operational. And these things, if the student who is trying from ENC or any other branch is getting an opportunity to do this experiential learning online, then they will be much more productive in their domain. I'm not even looking at the classwork. I'm looking at an out of classroom project which some group of students have come forward, and how do we help them? So now they can, once they get the idea how it is working, they can think about how to make the motor much more efficient, how to control the motor, control the speed, on a how to put a rain sensing sensor on the wiper, or maybe windshield can be with display. Many such things can be implemented. So the smartness which they wanted to implement had to be going through some other domain understanding. So that is possible if you have such facility to see. Similarly, if you're looking at an, I'll take another case of a hard disk. So assume the problem statement comes like this. The hard disk, when it is being read or written, some places it is getting a trouble because the hard disk arm is touching the writing surface. Okay, the magnetic material is getting gouged off, and it needs to be analyzed. The question is it a problem from electronics? Is it an embedded system issue, or is it a software issue, or is it an issue for mechanical engineers and civil engineers? I'm trying to convert this as for mechanical and civil and see how we are looking at. These are the components. We understand how it is working, and I'm converting this into something very simple as a cantilever beam. Then put the equations. In a general talk, we don't need to worry about how it is found out, but put all that things together and understand the physics behind it, convert that into an equation, make simulations, then find out what is happening. Okay, so this is exactly what we need, where if a student has experienced the concept, the learner will be able to implement and use that concept for finding a solution for a problem. So those who are already too tired of hearing me, just look at this question. You can respond. You can respond to the question. Okay, ventilation. Movement then has given it as a ventilation, fine. So think about a hole provided in a sophisticated hard disk. So please find out why is it required, because the hard disk, mechanical hard disk or hard disk which with the motor rotating at it is rotating at 7,200 RPM. Yes, I have some answers: assembly purpose, heat transfer, air pressure. Very good. It has more to do with pressure balancing. If it is close to chamber, when it is rotating at 7,200 RPM, the centrifugal force will create a lot of pressure. It need to be taken out. So this is called a breathing part. Okay. So here the point is, every part what we have in and around can be used to teach engineering, make it experiential. Okay. So from here, let us just see what is experiential learning. I'm sure if I take a group of students for 4-year course in swimming, make them sit on the swimming pool side and teach them every theory of buoyancy and flotation equations, probably all the theories of Bernoulli's and Navier-Stokes, etc. After 4 years, if I give them a degree, bachelor's in swimming, and ask them to start swimming, or do the same thing for cycling, I know all of you are laughing at me. And most often we are doing the same in engineering too. Can we do engineering and science rather than read engineering or science? That's a question we kept on asking. And that is what we are looking at from experiential learning. Can we make our students to do engineering rather than read engineering? And I'm sure that Guru from the textbook has changed to this. And now our smart students are looking at the likes and appreciations they get from their online posts. Can we use the same environment for providing experiential learning? And when we talk about experiential learning, this is what many of us think about. And if you're doing experiential learning this way, be ready for this. Otherwise, get into a computer and safety and start understanding or experiencing the concept. So that is what we are trying to see in virtual lab. So in order to create that virtual lab and how it should be, let us start dreaming. And we have 3 stakeholders which we are putting together: the administration, maybe the dean, director, dean, and principal and vice principal, etc., whom you go and ask for money for any modification in online class, or a professor who are already pushed, faculty who are already pushed, those who are so comfortable in chalk and talk now have to talk to the screen without seeing the students. But our smart students are so happy, they would always love to be online. Now the question is, how do we specify our dream in such a way that we get what we want? Okay, so I am dreaming about a learning management system and a lab that should be in my place, and that should be in my pace, and that should be in my time or my period. So 3 P's. So if I am a slow learner, I should be able to do it many times. And wherever I am locked down, I should be able to do the lab. And whatever be the time I am interested in doing it, assume that someone wants to do an experiment at midnight, 12 o'clock, and we should be able to allow them to do the experiment. Don't ask me what experiment. So that kind of a facility can be dreamed. And the same facility we should be able to take home or carry with us. Obviously, with no lock and key and no holidays. Fortunately, during this COVID period, we have forgotten the holidays. And for a student, it is also looking at, can it be comfortable or useful for my syllabus? And can I get a dream job using this lab and the concept? And those who are in the job, can they change the job or can they get into new area? And these are the concepts we have put together as our dream specification for the virtual lab. A lab and LMS at our place, pace, and period. And lab where experiment can be repeated, and it is 4 hour syllabus, etc. So this is what the Ministry of Education have done, the virtual lab under National Mission on Education through ICT. All the 7 IITs along with IIT Hyderabad, Amrita University, Dayal Bagh University, and COEP Pune along with NIT Surathkal developed virtual lab. And we hope similar kind of virtual lab can also be created in collaboration with NIDK and SRM, and we can make sure that every subject which SRM teaches have a virtual lab component, and it's available for the rest of the world, so that you can get advantage of being visible on a ministry site. So we are not only looking at to introduce you the virtual lab, we are also looking at how can we partner and make sure that the virtual lab flourishes with more and more labs being created. So there are three kinds of labs. One is modeling and simulation based lab. Second one is measurement based lab. And third is a remote triggered lab. So the concept is very simple. We need a physical lab or server at one location connected with internet, and the end user using the client machine connected to that and get the lab done. So you should be able to reach at vlab.co.in or rtlabs.nitk.ac.in. Now we are under lockdown, hence we won't be able to show you the RT lab because I know the lab have been kept closed. So this is a website. My team will obviously show you the details. I'm just taking one example of an ENC faculty was forced to look at our the case of the Viper. How we can help a faculty who is not from one domain, helping the students to guide them on a project otherwise. Okay, so here when you look at this, you can go to the corresponding area, that is your broad domain. And you can also look at the institutions. If you click on that, it will show you what are the labs which they have created. Okay, so I'll just quickly take you through one experiment on the way in which the Viper was moving and how you can help the students to understand that better without really attending one full semester. So this is a slider tank mechanism which is used as a part of the Viper, and if they want to understand, analyze and model it, there are provisions available. For a mechanical engineer, it is something which they do regularly on third semester in kinematics of machine or mechanics of machine, or sometimes it is called theory of machine. But the same thing can also be made provided for other branches if their problem statement has something to understand from this. So this can be used as an online tool for delivering the normal lecture and ask the students to experiment with this during the class itself. And you can get good feedback on that. Suppose the length of the connecting rod is increased, what happens? If the speed of the crank increases, what happens? All that can be easily understood from this itself. Then if you want to go to the next level, you can also do analysis with force, acceleration, and it can be done in such a way that you can remove the parts and find out what kind of forces, etc. comes in. From there, you can also take them to the next level where when something is getting excited, how the vibration levels are going to change, because the Viper is a member which is having a rotating motor which will be in the car, and that should not create too much of a noise. So if the electronics or other students have to understand what has to be done, then probably a basic understanding on this kind of domain also helps. So this way, the virtual lab is going to be useful for both online classes, to communicate and experience the concept, and also for interdisciplinary activity. And is it only for a UG students? Absolutely not. In fact, we have seen many research scholars using virtual labs so effectively because they can't go and ask some of the basic things to their guide. Of course, if I'm the guide, I will not entertain him asking a basic question. I say you go and read. Now, it is not only reading that basic concept, he can experience that concept and implement in the research. And we also saw that Mtech students using it because whenever they want to do a higher level of activity, their basics can be really refreshed on this. And the way in which faculty members used was really amazing. Many of them used it as a tool for the regular class. So they asked the students to explore and come back with questions, then explained how it is working. This was one mode which one of the faculty told us. Other way was he explained all the basic concepts, then asked them to explore and ask questions. So this way, we should be able to make use of virtual lab in every domain, because our team will explain you or at least demonstrate you few of the labs, and it is your wish to go through each of the lab, and there are 11 or 12 participating institutes who have developed the lab. You can go through every one of them. Everything is available free of cost. As being a nodal center of NITK, you'll also get special attention from NITK. And if your team is willing to develop virtual labs, we are willing to help you. We have tied up with IIT Madras Alumni Association parts, and along with them, we are helping around 29 institutions to develop virtual labs, and that is in a good progress now. That way, SRM Damapuram campus also can get involved through parts so that it can be useful to develop new labs. So with that, I am winding up. Thank you for a good opportunity to explain the concept of experiential learning, need for experiential learning, and how it can be used in a multidisciplinary environment, either for the classwork or for a project work, is what I, within a short time, I have explained. If there is any questions, I'm willing to take. Otherwise, we can continue with the demonstrations, and question could be at the end. Back to the host.
Very good presentation, Professor. Very good presentation. Impressive.
Thank you, Dr.
Thank you
Gangadharan.
so much.
Do you like to take 2 minutes for questions, or we'll go to the demonstration?
I think we can take up the question, and then you can proceed with this one. Then you can respond to those questions, I think.
Anyway, I don't see any questions in the chat box. If someone would like to ask a question, can ask. Otherwise, my team will continue. Beryl, then can you continue?
Yes, sir. Sure. Sir, just to add to what you were mentioning about PALS, actually one of the constituent institutions of SRM itself is there as a part of the PALS initiative. The Katangalattur campus is already working with us.
Oh, very good.
So, sir, shall I continue or should we wait for some questions?
No, before that, if principal or dean would like to answer this question, like, it will be good the institute like SRM to get involved and start developing labs along with NITK, so that we can say we together providing solutions for on edutech, so that it can be so visible that SRM and NITK together provides. Just think about another 100 labs developed together.
Sir, thank you, sir. Sir, we'll go ahead with that one. And in fact, your presentation is very informative, and with the 3D pictures and other things, etc. But it will be because the present situation, there is only one alternative, sir. Maybe in future we do not know what will be the condition. We have been just counting the days for the past 1 year, but I don't think so this situation will come to normal. But there is only one alternative source to reach the students at reasonable resources. There is only virtual labs. And we definitely will go ahead with this NIT Surathkal, sir. And thank you very much for giving this opportunity. Obviously, all the departments, HODs also be there in the present session. And our Prabhakaran sir is also given initiative. Definitely will take this task to the maximum level, sir.
Okay, thank you. So then, probably if no other comments, Beryl can take over.
Okay.
Yes, thank you, sir. So very warm good morning to all the dignitaries, the senior members of SRMIST Ramapuram campus, and all the HODs, faculty members. So myself, Beryl Thomas, I am a senior research fellow under Professor K.V. Gangadharan at the Center for System Design at IIT Surathkal. We will be taking over you through a few demonstrations of labs from all domains of engineering today. So specific to mechanical engineering, civil engineering, circuit engineering branches, electronics and electrical engineering, and computer science will be the subjects that we will be taking into consideration during the demonstration, we are exploring the options of conducting a separate session for physical sciences, chemical sciences, as well as life science branches, biotechnology, biomed engineering branches, and chemical engineering separately on a different session. So now we will be moving into a presentation of or demonstration of a few sample labs from the virtual labs platform. So before that, I will quickly go into show you the virtual labs basic outline before going into domain specific demonstrations. So I have started sharing my screen. I hope it is visible. Can I get a feedback, sir? Sir?
It's visible.
Yes,
The screen is visible.
Yes, sir. Yes, sir. Visible, sir.
Thank you, sir. Thank you. So this website. So the entire resources that are there that have been published as part of this initiative, it is available on this web portal on the URL vlab.co.in. www.vlab.co.in is the URL where all the resources specific to this particular initiative is hosted. And here you can find all the basic theoretical information, all the objectives of virtual labs, etc., and the participating institutes that have contributed, all these things that have already been discussed by Gangadharan sir. And here we have the list of 9 broad areas, 7 areas of engineering, and 2 basic science areas listed here. And this is the way in which you have to go into any specific domain. So if you are looking for a lab in electronics and communication, you will have to click that broad area from the home page, and you will be taken to a list of labs that is available in the domain of electronics and communication, and corresponding to each lab, the name of each lab, you will see the name of the institute that has developed it as well. So this is how in general the site has been structured, and sir has also mentioned that each lab, so each lab is the name of a single unit, basic unit in the virtual, and in each lab we have multiple experiments. So each lab think between 5 to 15 experiments specific to that particular course in engineering. All the engineering subjects, we have a lab, practical lab course, and we have multiple experiments there. Likewise, the lab is also structured. And within this lab, we have learning management system. So it will have a theoretical material. So theoretical material can be in the form of textual notes, concept notes, visualizations, video tutorials. There will be multiple ways in which theoretical materials have been presented in each one of these labs. And there will be simulations. So virtual simulations is the core of virtual labs. The simulated, animated versions of real world experiments or real world machines, apparatuses, circuits will be what will be basically having in a virtual solution, and we'll be having some elements of evaluation as well. Evaluation tools like MCQs based on theory as well as MCQs based on the simulation or the practical component will also be available within inside each one of these labs. So this is how labs have been structured. And one more thing to point out at this point is that looking for a particular subject, you may encounter situations that you may not be finding it listed under that particular lab, particular broad areas. So if you're looking for a lab in mechanical engineering and you're navigating the list of labs in mechanical engineering, you may not always find all the labs for mechanical engineering listed under mechanical engineering itself. You may find some of the labs to be listed under engineering also, or you may find something relevant under physical sciences, or if you are looking for an interdisciplinary branch, you may find some resources in electrical or electronics. So likewise, there may be situations of overlapping as well. So whenever you are looking for a particular lab, you may have to navigate through the list of resources available on related broad areas as well. So mechanical and civil may have several overlapping resources. Technical may have several resources. And likewise, even computer science and electronics may also have resources. Under computer science, we have many resources, many labs, subjects like VLSI, signal processing, etc. listed under computer science, and many labs relevant to computer science like digital electronics, basic electronics are listed under electronics. So likewise, overlapping is there definitely. And even gap areas are there. That's what Sah has been mentioning about development. So according to the ministry's assessment, ministry that we may need to create more than 500 labs, virtual labs, like the ones we have seen listed over here right now. There are around 25 labs that have already created and published on this platform. So likewise, we may require to have more than 500 labs to cater to the requirements of the academic community across all universities in the country. So that's the target we are looking at. So definitely there are gap areas, and whatever resources that are available on this VLab homepage is the main set of resources. And there is also one more point where you can look for resources, that is the new lab development page. So there is a link called new lab development on this homepage, and clicking that will take you to the developer portal of virtual labs. So the developer portal is the place that centralizes all the development activities of virtual labs. So whomsoever is interested in lab development can definitely have a look at the resources that are available on this page. So I hope you have already seen it is available on new lab development link on the VLab homepage itself, and it will take you to the developer website, and it has some tutorials, workshop materials, etc. pertaining to development of virtual labs as well. So development, it is completely an open source resource, open source platforms that are used for development of virtual labs, and you can look up more information in the tutorials as well. And you have one link called Explore Labs here, and Explore Labs has two links: approved labs and labs under development here. So these two links actually takes you to resources or labs that are under development. So list of labs under approved labs, it is actually the resources that have complete development and are pending for different levels of evaluation. So there will, being a central government funded project, has done very elaborate levels of evaluation that is taken place before it is getting published to the main page. So that process takes a little bit of time, and over that time, the resources evaluation will be over here. So all these resources will be usable. They will all be complete usability. But before getting published, it will be available on this page. So if you are not able to find a particular resource on the main page, vlab.co.in, you may look up such resources on the developer page as well. Some labs that have been, so you may come across that are Flash based. So Flash has reached end of life a couple of months back. So Flash based labs are in the process of getting replaced with HTML5, and you may even find such kind of resources that were earlier developed with predated technologies that have been updated with latest browser technologies available on this portal. Likewise, this is how labs have been structured on the VLab platform. So I'll stop my screen sharing right now. And as we have mentioned in the schedule, we will go into lab-wise or topic-specific demonstrations of virtual labs. So we'll be starting with core engineering branches, specifically with mechanical engineering. Mr. Rohit Kushwaha will be demonstrating the labs from mechanical engineering. So Rohit, over to you.
Thank you, sir. Am I audible?
Yes, Rohit, you're audible.
And please give me feedback for screen sharing also. So I'll share my screen now. So is my screen is visible, sir?
Yes, sir. Rohit, sir.
Yes, sir. Yes, sir.
Thank you. So, good morning everyone. My name is Rohit and I'm a junior research fellow in Center for System Design under KG Gangadharan sir. And today we'll be exploring few of the labs from mechanical engineering. So, some of the uh, experiments that KBG sir has already explained, like from mechanics of machine, like vibration lab. So, from that lab only, we'll explore some different experiments and we'll explore the user interface, environment, and all other things related to those labs. And so right now I am on the mechanical lab page. So as we have seen from the VLab website, we can go to broad area. Then from that we can choose mechanical lab. So currently I'm on the mechanical lab page, and as here we can see the available labs over here. So we'll explore some of the labs from NITK, and if time permits, we'll explore some few other labs also from different institutes. So let us explore the mechanics of machine lab. So here is the mechanics of machine lab, which I have already opened. So here's the mechanics of machine lab. So once we open the lab, we'll find important information about the lab, the subject which we are going to explore. So as this is a mechanics of machine lab, so we have the introduction. So over this tab, we can find our experiments, our introduction, and related information like course align, prerequisites, feedback, and target audience. So in introduction, we can find some basic information about the subject and uh, some important definitions and other things. So before starting the lab, the experiment, if the user is very new to the concept, they can take a brief understanding from this and they can continue. So let's go for experiment. So once we enter the experiment, we'll be finding the available experiments in the lab. So over here we have more than 20 number of experiments, and all the experiments we can find here are related to mechanics of machines. So some few of the starting experiments are FOBA mechanism, then slider crank we have already seen, as sir has shown that. And then we have the straight line mechanism, some clan mechanism, cam mechanisms, and also we'll figure out these things. So let me just open one of the experiments. So over here we have the acceleration analysis of Grasshopper FOBA mechanism. So we have seen the slide crank mechanism. So let's explore the FOBA mechanism. So let me select the experiment. So once we enter into the experiment, we'll find the important information about the experiment that we are going through. So as this is an acceleration of a FOBA mechanism, so we can find important equations and relations for acceleration of the FOBA mechanism. So once we enter into the experimentation, we'll find the theory that is important if the user is very new to the concept. Then there's a procedure. So procedure is basically the here the procedure will guide you how to simulate a simulation. So if a user is very new to the VLab and if they want to guide themselves how to execute a simulation, they can read a procedure and they can follow it. Then there's a self-evaluation, so which basically contains MCQ questions. So before attaining the simulation or after that, you can check their knowledge. Then finally, there's a simulation that we will check. And there are some other things like videos, references, quizzes, and assignments. So let's go for simulation. So as Viren sir explained, the Flash player is not working right now. So we need to select all the experiments with the non-Flash user. So we can select this. Okay, so over here, the main aim and the objective of the simulation is to find the acceleration for each of the link in the FOBA mechanism. So over here, we can see the main experimental page is divided into three parts. So the first part, that is in the center, we have the experimental setup giving some information about each link. Over this table, we'll discuss it. Then there's a variable. So variable is the part where we can actually simulate the simulation. So we have the user will have the freedom over in the variable tab to change some of the variables and try to understand what are the changes after changing those variables. And finally, we have a control panel where we can play or pause the simulation or some other options as well. So here we have the rotation, that is, we can make the simulation to run into clockwise or counterclockwise direction. So let's see what is happening over here. So I'll pause this. So over here we have a position diagram. So basically we have a 4-bar mechanism, and the AD, that is bottom link, is fixed over here. And from here we can find the related information like R1, R2, R3, and R4 is related to the links AB, BC, CD, and AD. And then we can change each of the links. So in the variable, the R1, R2, R3, and R4 we can change. And right now the link length R1, that is the AD, is 80 mm. So we can change it, and just we need to make sure the combination that we are changing should satisfy the Grashof rule. So once we violate that, it will give us a notification kind of thing over here, and that we have to make sure that it follows the Grashof rule. So we need to keep the combination in such a way. Let's just make it like this. So once we are done, we can set a particular angle at, if we want to calculate some value at a particular angle, and then when we are set with the combination, we can play it. Then after the position diagram, we have the velocity diagram and the acceleration diagram. So in the table, we have all the information related to all the links. So over here we have the link length, so that we have set up over here. Then we have the angle, so angle related to R2, and for each of the angle, then we have the angular velocity, then we have velocity, then we have alpha, that is angular acceleration, the centripetal acceleration, tangential acceleration, and overall acceleration. So for the acceleration diagram, we can find the legends over here. Let's just keep the angle in such a way we can find we can see the acceleration diagram properly. So we can zoom over here, we can find the all the related acceleration part over here. So this was one of the explore phase, and we can explore while changing the link length, and we can keep the link length, and we can find the motion of the 4-bar mechanism, and related to that we can find the velocity and acceleration for each of the links, which can be calculated from this part. So I'll go back to the experimental page. So as we have seen there, the Grashof tools we need to make sure, and we need to keep in mind, and we need to change the link length. So if user wants to keep the 4-bar mechanism in such a way, they don't want to follow the Grashof tool, and they can make all the possible combinations, then we can use the acceleration analysis for non-Grashof 4-bar mechanism. Then we have the slider crank mechanism that we have already taken a glance and sir was explained. So we'll see some of the others like straight line mechanism or some cam mechanism. So let me open an acceleration analysis of Scorpio mechanism. So again, we have already seen the page setup. So we have theory and all other things are similar. So let me just go to the simulation for non-flash users. So again, we have the setup very same. So the variables, controls, and the experimental setup. So over here we have the Scotch mechanism, and in the variable we have a option to change the crank length. So currently it's 40 mm, and we can change it from 10 mm to 100 mm. And once we do that, we can see the change in the simulation, and we can see the end point distance as well. If we can pause it, we can keep it to any particular angle that we want, and over here we can find the calculation of the acceleration for each of the degrees. So we can get the acceleration value from here. So let's just play it, and we have the angular velocity. So we can change the angular velocity from almost 0 to 2, and while doing these changes we can find the velocity, acceleration, and position graph with respect to time. So let's just go in the control panel, and we can we have discussed, we have the direction button over here, and we can play and pause. Let's just check this show graph checkbox. So once we do that, we'll see graph has been plotted with respect to time, and in the amplitude we can find we have the position, acceleration, and velocity that we can see from this legend. So yeah, so we can check the displacement and the acceleration and the velocity changes from the graph. So let's just change the crank length from 46. Let's just make it to around 70 to between 70 to 80, and then let's see what will be the changes. And we can increase or decrease the velocity, and then also we can change. So let's decrease the velocity to the minimum and let's see the amplitude. So all the related combination we can check from here, and if we increase the omega, and then we can find the amplitude has been increased, and which the acceleration is too much, and position and velocity. So like that we can analyze the velocity acceleration in a visual manner, so which I think will increase the cognitive level of a user very effectively. So let's go back for the experiment. We'll see one or two experiments and we'll go to the next lab. So as discussed, we have the cam mechanism. So let's open elliptical cam mechanism. Go for the simulation. So in the cam mechanism over here, we can see a cam which is rotating on a follow and a cam and a follower mechanism in the center. And in the variable, we have the geometrical variables, that is the major and the minor for elliptical cam. And then we can check for the similarly with acceleration, velocity, and position and jerk of the cam mechanism. So let's just keep everything same in the variable, and let's go for graph. So once we check the show graph checkbox, we can get the graph for position, velocity, acceleration, and the jerk. Now let's change the omega. So let's keep it very small, and again we can find there's very the change in the velocity and related to that velocity, acceleration, and the jerk. And let's just increase it, and we can play around the geometrical, and if we keep both for the dimension same, then there will be no changes, very small changes, and we can make it very aggressive vertical cannon, and we can check for other things. So yeah, like that we can check for the velocity, acceleration, and the position diagram. So these were some of the few labs from the mechanics of machine lab. So basically all the other labs in this, all the other experiments in this lab are, we can execute them in a similar fashion. And if there's a problem, we can check for the procedure as well, which will guide us how to go for the simulation. Now let's check some of the new labs. So I'll go back to the lab page over here. So there are some new labs that is new lab that is dynamics of machine lab. So let me just open this. So as we can see, the dynamics of machine lab, the user interface has changed. So as this is a newly developed lab, so it is different but very similar to what we have already seen. So once we enter into the lab, we have the important introduction, then objectives, list of experiments, and other similar things. So let's go for list of experiments. So this is the dynamics of machine lab. So as the sir has shown a slider crank mechanism about the dynamic analysis for that. So we'll check some other labs. So as we have seen the kinematic analysis of Koba mechanism, so here we can do the dynamic analysis like calculation of the acceleration of CG of the center point of a link or some offset analysis. So that I hope anyone can go and explore that. So let's just see other experiments. So go for role governor. So the aim of the experiment is to find the important relation between the RPM and the height, and the mass and the height of a governor. So we have the theory and introduction as we have seen earlier. So important relation formulas, some free body diagrams to explain it. more properly. Then there's a t-test. T-test is again contains basic MCQs to go through and test their knowledge. And procedure as it will guide us to how to execute a simulation. Let's, let's go for the simulation. So in the simulation phase is very similar as we have seen from the previous lab. So in the center, we have the setup of a parole governor in the front view and the top view. Then we have a free body diagram, which gives a very better understanding while we are understanding a governor or something like similar. And in the variable tab, we have two of the variables, that is RPM and the mass. So user has the freedom to change RPM and the mass, and they can relate the height of the governor with respect to mass and the RPM. So let's check. So currently the RPM is 100, and here is the height that is displayed, and we can get this thing from the animation as well. So let's just change the RPM from 100 to the maximum, that is 130. And as we can see, so height decreases from 240 to 250 to 150. So we can see the relationship of RPM with respect to the height. So this is, as the RPM increases because of the centrifugal force, the height, the governor will go up. And similarly, let's see what will happen if we increase the mass of the fly ball. Again, we can see if we are increasing the mass, because of the increased mass, the height is again decreasing more. So this is like simulation part of the simulation. We can explore over here that what are the related variables will make effect on the height. So over here we have two options in the control panel. So that one is show graph checkbox and one is go to experiment. So let's check the show graph checkbox. So over here we can get a graph plotted between the RPM and the height, and we can get any of the values by hovering our cursor over the graph, and we can get a related value for RPM and height. So this was the explore part. So once we are done with the explore part, let's go for the experiment. So in the experiment, we can do immediate calculations and we can identify the part of the governor. So after the doing the simulation, and if we're doing an experiment like for calculation or something, which is a very better understanding for any of the uh, experiment that we are doing. So currently over here, we have to find the mass of the fly ball, and these are the constant variables. So that is Fm by Bm. That is, we can get it from the free body diagram. The mass, the overall the mass is constant variable is 20 kg, and if and for finding the mass of the fly ball, we need to find the RPM and the height. So RPM and the height we can get from the variable. So let us reset the experiment. So every time we reset the experiment, all the variables and uh, all the variables will change, and every time we reset the experiment, we need to do a new calculation, which gives very better understanding. So right now we need to find the height. So let me just put some value and let's check. So every time user do an experiment, they need to calculate their answers, and they need to check it from the uh, experiment. So once we put a value, then we can find if the answer is correct or not, and we will get a correct value over here. So we can reset multiple times. On every time we reset, the experiment will change. So right now we need to find the RPM, and we need to check it, and we need to know, and we need to compare it with the simulation results. So this was the calculation part. Then let's exit the experiment. Then there is the identifying the part of the governor. Let's start the experiment. So this is basically simply a picture of a parole governor, and the user need to find the part name. So let's say this is fly ball. So once we do that, there's a small check mark feedback will be given if the selected answer is correct or not, and if not, it will give us a wrong answer. So let's go back to the experiment. So in this experiment, that was that, and so basically in the new lab, all the experiments have the explore and experimental phase, which will help the user to understand the concept properly. So let's check one of the experiment, that is balancing of mass uh, in a single place. So in this experiment, in this simulation, the aim of the simulation is to find the balancing to balance a mass in a rotating single plane that is on a shaft. Then let's see, all the options are same, so we'll go for the simulation directly. Over here we can see two of the masses that is named M1 and M2 are rotating on a shaft. So this is the top front view, this is the side view. And in the variable we have the option to change the masses. So this is basically a process, so we can keep the masses according to our need. So let's say we'll keep it like this. Then the R1 and R2 are the link lengths of the mass with respect to mass M1 and M2. And let's pause it and we can find the angles, and for the legend is available, what angle belongs to what. And let's change the angle and again play it. So we can see the change in the angle. Then in the control panel, we have this option to move it in clockwise or anti-clockwise. So once we are done with the simulation setup, we can go for the next page. And on the next page, we have the experiment. So now the thing is, we need in the simulation, whatever the setup we have done, like masses that we have changed and the link length that we have changed. So now we need to balance this particular shaft. So we need to calculate the mass which is required to balance this whole setup, and the link length at which it needs to be kept, and the angle at what have to be kept. So let's just keep some value, let's say 500, and angle also will change, something like that. So once we enter our value, you can see a new red color with a name B, that is the balance mass, has come over here. So once we are done with our calculation, so user will calculate the thing, calculate the balance mass and the related angle and the link length, and we can submit it, and we can compare how much is the correct answer. So we can, every time we can go back, we can set up the simulation according to our need, and we can calculate and we can find if the related answer is correct or not. So basically it gives the information and fulfills the aim of the experiment, how to balance a particular rotating mass. And this is for the single plane. If the user wants to go for the multiple planes, so yeah, for the multiple planes. So these were some two of the experiments from the dynamics of machine lab. Go back for the lab page. And in the lab page, we'll quickly see some lab from the other colleges as well. So let's check the micro machining lab from COE Pune. So this is over here, we can find the lab page, and we'll go for the list of experiments. So in the list of experiments, we have different number of experiments. So let's just explore one of the experiments. So there's a study of electrochemical machining process. So just like the previous experiment that we have seen, like the dynamics of machine. So the user interface of the lab is like similar. So we have aim, objective, pre-test, which basically contains questions, prerequisite, theory, which is like important relationship information and equations is there. Then there is simulator, then other things like post test and conclusions, results, and feedback. So let's go for the simulation. So this is the simulation page for the electrochemical process. So over here, the aim of the experiment is basically to understand the whole process of electrochemical machining process, and to here we can estimate the removal rate of the material from the part. So as we can see, this is the electrochemical machining process. So we have two of the part over here, that is working piece, which is this, and then we have a tool. So the working piece is in anode and the tool is in cathode. And over here, the final potential difference will be given for 10 volt. And in the control panel, so basically over here there's a proper setup of the simulation, and in the control panel we have the metal to select from. So from the drop down we can see a lot of metals to select from. So let's check aluminum. So once we do that, the atomic weight will come, valency we can select, and the removal rate we can select from here, and it will give us the removal rate according to the selected material. And from here we can find the removal rate is 1000 here, and the anode current efficiency is 100%. So the rate at which the material is removed from the anode is inversely proportional to the distance between the electrode, and that we can see from here. So let me just start the experiment or just start the whole flow pattern. So when the power supply is opened from the electrolyte reservoir, we can see a pump is pumping the electrolyte from the filter. It will go to the tool, and from tool it will be hit on the workpiece, and once it is hit on the workpiece, it will cut the material and all the waste will be collected and be taken over to electrolyte, and then again it will filter and go back to the electrolyte reservoir. So this is a basic machining process which is being explained in a proper animation way. So, and over here we can select any of the other metal and we can check the other cutting removal rate and other options. And we have some advantages of this particular process, that is the removal rate does not depend on the metal. So, and it is there's no wear in the tool and other things. So let's go back for the experimental page. So yeah, like that we can explore any of the labs from the mechanical lab page. And currently we have seen 3 or 4 labs. So right now, because of the time constraint, I'm going to stop my demonstration and I'll ask Aishwarya ma'am to take over for the civil lab. And thank you.
Thank you, Rohit. Good morning, everyone. I'm Aishwarya Hegde, working as a senior research fellow at Center for System Design, Nmeict-Virtual. So I'll be demonstrating on a few of the civil engineering based labs. I hope I'm audible.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yeah, I'll be sharing my screen. I hope my screen is visible.
Yes, ma'am.
Yeah, so as I said, I'll be demonstrating on few of the civil engineering labs. So as you know, to access the lab, you have to go to the vlab.co.in website. And if you scroll down in broad areas of virtual lab, there will be different disciplines of engineering where you can perform the experiments. So I'll go to the civil engineering domain. And in civil engineering domain, as you can see, there are more than 14 labs that are developed by various institutes. So there are multiple labs developed by IIT Hyderabad, NITK Surathkal, IIT Delhi. Then there are labs developed by IIT Roorkee, IIT Delhi, etc. So we'll see few of the labs here. So let's just start with the strength of material lab. So this particular lab is common for both civil and mechanical engineering students. So I'll go to list of experiments where I can see the experiments in this particular lab. So you can see here in list of experiments, there are about 14 experiments. Most of them deal with the testing of materials. So there are different types of impact tests. Then there is different types of hardness tests. There is Rockwell hardness test, Vickers hardness test, Grinnell hardness test. Similarly, there are experiments, UTM based experiments. So we'll see one of them. Let's say we'll start with the IZOD impact test. So when I go to the experiment, yeah, so the format of the experiment will remain same as it was demonstrated by Rohit. So there is simulator where you'll be performing the experiment. Then there is theory, there is procedure. So before we go to the simulator, we'll just go to the section called procedure. This section should not be confused with the procedure to do the experiment. Basically here, they'll give you a detailed explanation on how exactly you have to do the simulation. So it will give you instruction on where exactly you have to click while performing the simulation. So you can just refer this section before we start with the simulation. So when I go to the simulator, the objective of the experiment is defined, the apparatus used is shown. So the objective is to find the impact resistance of mild steel and cast iron specimen. So basically we are measuring the toughness of the material. Then the apparatus is shown, that is the impact testing machine. So let me just click next. Now the user is given an option to select the type of specimen. So he's given with two options, cast iron and mild steel. So I'll select one of them, let's say mild steel. When I select the mild steel specimen, the dimensions of the specimen will be shown. So the dimensions are noted down and then I'll click on next. So in the first step, what we'll do is we'll measure the loss of energy due to friction. For that, we'll pull this lever so that the hammer will strike the anvil portion. And as of now, there is no specimen placed in the anvil portion. By doing that, we can measure the loss of energy due to friction. That is about 4 joules. I'll click on next. Now, let's start with the trial 1. So first what we'll do is we'll place the specimen in the anvil portion. Since it is the izod impact test, the specimen is placed vertically and the notch is facing the direction of the hammer. So I'll click on next. So you can see here in the experimental setup, the notch is, the specimen is placed in the anvil portion vertically and the notch is facing the direction of the hammer. So this is the zoomed version of that. So I'll pull this lever so that the hammer will strike the specimen. So what has happened in trial 1 is the test specimen is not broken by the striking energy of the testing machine. So let's just click on next. So in this particular trial, the readings will be considered nil. Then I'll click on next. Then I'll continue with trial 2. For trial 2, new specimen of mild steel is taken. The dimensions are given. We'll note down those values and then click on next. So again, we'll pull this lever so that the hammer will strike the specimen placed. Then we'll measure the loss of energy during the transit of hammer. It's about 48 joules. So then we'll click on next and then we'll measure we'll calculate the energy for failure of the specimen. That is 48 joules minus 4 joules. That is 44 joules. So 4 joules is the loss of energy due to friction that we calculated in step 1. So I'll click on next. Now again for trial 3, we'll repeat the same steps. Pull the lever so that the hammer will strike the specimen, then measure the loss of the energy during the transit of hammer. It's 41 joules. Then calculate the energy for failure of the specimen. That is 41 joules minus 4 joules. That is about 37 joules. So I'll click on next. So once all the 3 trials are done, the observations of the 3 trial readings will be shown in the table. Then we'll calculate the average energy for failure of the specimen. That is average of the 2 trials. That is about 40.5 joules. So this was one of the experiments in the strength of material lab. So as I said, there are many other experiments here. So you can, as I showed you in the first place. So you can see there are multiple experiments which you can see in your free time. So I'll just go back to the civil domain site and explore other labs. So when we scroll down through this site, you can see there are multiple labs that are developed in fluid mechanics and hydraulics subject. So there is a lab developed by IIIT Hyderabad, that is hydraulics and fluid mechanics lab. Then there is another lab called fluid mechanics lab developed by NIT Surat. So in the newly developed lab, so you can see there's fluid machinery labs. So we'll see one of the experiment labs in the fluid mechanics domain. So let's just go to the list of experiments. So here there are in fluid machinery labs, there are about 7 experiments. So you can see most of the experiments are related to performance characteristics of various turbines and pumps. So we'll see one of the experiments here. The look and feel of this particular lab is a little bit different compared to the previously demonstrated lab because these are newly developed labs hosted by IIT Bombay. So you can see here the aim of the experiment is to conduct a performance test on the Francis turbine under various head and speed conditions. So we directly go to the simulation. So here you can see there is a pre-test and post-test. These are new sections added in the newly developed labs. So basically it will have quiz questions which the students can take before performing the simulation and after performing the simulation. So I'll go to the simulation directly. Here in simulation, there is 2 options, Francis turbine under constant head condition and Francis turbine under constant speed condition. So you can select one of them. So here, if you see in the right side, there is a section called pop-up procedure. So basically, we're doing the experiments. In case you get stuck in between, instead of going back to the procedure and referring the procedure section, it's better you refer this section where you'll get a detailed explanation on how to do the simulation. So in the simulation, the objective is defined to conduct the performance test on Francis turbine under constant head and speed condition. So apparatus is shown, and then there's a section called description where important definitions related to this particular experiment will be shown. So I'll click on next. The first step will start the pump by clicking on the green button. Since it is a constant head condition, the user is given an option to select the head. So I'll select the head as 11 meter, then I'll click on OK. So here there's a question popping up. Selected head value is constant throughout the experiment. Say true or false. So from the drop down menu, I'll select it is true because what we select here in step 1, it will remain constant throughout the experiment. So I'll click on next. Now I'll open the inlet valve to keep the pressure constant. So click on next. Now we'll start with the first trial. In the first trial, there's no weight applied on the pan. So the readings are as shown here. So based on the observation readings, we'll calculate the torque. So the formula to calculate the torque is given. So you can see, use this formula and calculate and enter the value. So I'll click on check. So the torque is 1.47 Newton meter. So I'll click on next. Now we'll insert a tachometer to note down the speed of the motor. Since it is a constant head condition, the speed of the motor will vary for every trial. So I'll be inserting a tachometer to note down the speed of the motor for this particular trial. It's 1750 RPM. So I'll click on next. Then note down the hook gauge reading. The initial and the final readings are noted down. Then we'll calculate the head of water, that is final reading minus initial reading. Then we'll calculate the actual discharge. So the formula to calculate the actual discharge is given. Based on observation reading, we'll calculate and enter the value. So if you see in the formula, there are some constant parameters like coefficient of discharge, length of the wire, etc. Which in case you don't know, you just refer this section and use it in the calculation. So I'll calculate and enter the value. So actual discharge is calculated. Here there's a question. Francis turbine is it's a reaction turbine. So click on OK and then click on next. Under Francis turbine constant head, addition of weight increases the speed. Say true or false. It is false. So I'll click on OK. So these questions are added so that the experimentation does not become monotonous and the students are invested while performing the experiment. In case while giving, if the students give a wrong answer also, the students can continue with the simulation because the correct answer will be given automatically. So now, once we're done with trial 1, the observations of the trial 1 will be given. Based on that, we'll calculate the input power. So the formula to calculate that is given as well. So I click on check. So I've entered a random value. So in case in the calculation part also, in case the students give a wrong answer, they have to just click on results and the correct answer will be given directly. So then we'll calculate output power in watt. Then we'll calculate efficiency. Efficiency is given by output power by input power into 100. So efficiency is calculated in percentage. So finally, we'll calculate unit power in watt, unit speed in RPM. And then finally, we'll calculate the unit discharge in meter cube per second. So once you're done with the calculation of trial 1, for trial 2, some weight is applied on the pan. For that, we'll calculate the corresponding torque in Newton meter. Then click on next. Now we'll insert a tachometer to note down the speed of the motor for this particular trial. It's 1630 RPM. Then we'll note down the hook gauge reading. So we'll calculate the actual discharge. So head of water is calculated by, as I said, it is final reading minus the initial hook gauge reading. So click on OK and then click on next. So now, again, for trial 2, we'll calculate input power, output power given by 2 pi nt by 60, where n is the speed of the motor for this particular trial and t is the torque calculated for this particular trial. Then we'll calculate the efficiency in percentage. Click on check. Then unit power is calculated given by output power by square root of h cube, where h is the constant head that we are maintaining. So it is about 11 meters. Then finally we'll calculate unit speed and then unit discharge. So now for trial 3, again the weight on the pan is further increased. So we'll calculate the corresponding torque. Click on check. Then click on next. Now insert a tachometer to note down the speed of the motor. So it's about 1580 RPM. Then note down the hook gauge reading. Calculate the actual discharge, and then Francis turbine is located between high pressure water source and low pressure water exit. So click on OK and then click on next. So finally for trial 3 we'll calculate the same parameters. Then we'll calculate the efficiency in percentage. Unit power is calculated in watt. Then unit speed is calculated in RPM. So it's given by N by square root of H. N is the speed of the motor and H is the constant head that we are maintaining. Finally, we'll calculate the unit discharge. So now once we're done with 3 trials, we'll stop the pump by clicking on the red button. So click on next. Now we can increase the number of trials by increasing the weight on the pan. As of now, we have increased the weight up to 3 kgs. So for more number of trials, we can increase it up to 5 kgs. So click on next, and then we'll plot the characteristic graph of efficiency versus unit speed, unit power versus unit speed, and unit discharge versus unit speed. So this was one of the experiment in the fluid machinery labs. So let me just go back to the civil domain. So as I said, there are multiple labs developed. There's a transportation engineering lab developed. So basically it will have all the experiments related to highway material testing. So you can see here, there are 8 experiments in this particular lab. Then there is labs related to environmental engineering. So there are 2 labs, environmental engineering 1 and environmental engineering 2. Similarly, there is a lab related to mining geology and marine structure engineering. So I'll just show you the marine structure lab. So this in this particular lab, so if you go to list of experiments, there are about 7 experiments. So here only 2 of the experiments are related to core marine structure engineering. Other rest are related to the concrete engineering lab as well. So we'll see one of the experiments, let's say the slump test. So the aim of the experiment is to determine the workability of concrete mix. So we'll jump to the simulation directly. So the objective of the experiment is to determine the workability of the concrete mix. So the apparatus used is shown. So there are some definitions in the description as well. So click on next. So in the first step, we'll measure the volume of the slump cone. The formula to calculate the volume is given and the dimensions are given. So we'll calculate and enter the value. So the difference in the radius of the slump cone from bottom to top is it's 5 centimeter. So click on next. So now we'll fix the mixed proportionality ratio. So it's fixed as 1:2.7:4.2. And then the formula to calculate the cement content is given and some other observation readings are given as well. So using that, we'll calculate and enter the value. So just click on check. So similarly, we'll calculate the fine aggregate that needs to be taken and the coarse aggregate that needs to be taken. So once we are done with the calculation, we'll measure all these quantities. So based on the calculations we did, the about 1.6 kgs of cement is taken and about 4.3 kgs of fine aggregate is taken and about 6.7 kgs of coarse aggregate is taken. So once the measurements are done, we'll take the measured quantity of calculated quantity of water, that is about 670 ml. So mixed proportionality used in the experiment is 1:2.7:4.2. So click on next. Now mix the measured quantities of ingredients that you have taken, the coarse aggregate, the fine aggregate, and the cement. Mix it using a trowel to form a dry mix. Now, okay, quantity of cement used in the experiment is 1.6 kgs. So click on next. So for the dry mix, we'll add the measured quantity of water and then mix it using a trowel. So the mixing is done such that there is no lump formation in the concrete mix that we are preparing. The quantity of fine and coarse aggregate used in the experiment is it's 4.3 and 6.7 kg. So click on next. So now place the slump on the horizontal base. and then transfer the concrete mix that you prepared to the slump cone using a trowel. So the transfer is done in 4 layers. So as you transfer each layer, the layer is compacted using a tamping rod by giving about 25 number of evenly distributed blows. So now the second layer is transferred to the slump cone. So the compaction is done to remove the air voids that is present in the concrete mix. So now we'll compact the second layer using a tamping rod. So now the third layer is transferred. So now the third layer is compacted using a tamping rod. So we give about 25 number of evenly distributed blows. So finally, the fourth layer is transferred. This is the final layer. So the final layer is compacted. So the purpose of tamping is to obtain a uniform compaction in order to avoid voids. Say true or false. It is true. So click on next. Now we'll remove the excess amount of concrete that is present on the slump cone. Each layer of the mix is stamped for 25 number of times. So click on next. Now detach the slump cone on the direction. So click on next. Now measure the difference in the slump and the slump using a measuring scale that is up to 18 centimeter. So the height of the slump is 30 centimeters. So click on next. So for the water cement ratio we took and the mixed proportionality we fixed, the slump value is about 18 centimeters. So this was one of the experiment in marine structure lab. So as I said, there are multiple labs that are developed by different institutes, which you can explore on your own. So this was about the simulation based lab. So I'll just introduce you to one more section, that is the virtual tour of these labs. During the pandemic, although lab education became mostly using the simulation based lab, so a new section called the virtual tour of these labs was introduced. So in our site called rtlabs.nitk.ac.in, there's a section called virtual tour. So this is a project which is in pilot mode. So here there are only 3 labs that have the virtual tour facility as of now. So let me just show you the strength of a virtual tour of the strength of material lab. So for students who have never visited the campus or who have never even gone to any labs in the institutes, and who are learning using the simulation based lab, so this will give you a tour of the labs facility that is available. So this is basically the strength of material lab in our institute, NITK Surathkal. So this is how the lab looks like, and these are the facilities that are there in the lab. So other than the tour of the lab, when the students study the experiments using the simulation based mode, so they'll not know how the experiment will look in real. So you can go to a particular experiment. So I'll just go to the impact test experiment, since we have seen the simulation of that particular lab. Yeah, so this is the experimental setup. This is the impact testing machine. So so this is the anvil portion where you will place the specimen. If it is a ISOD impact test, the specimen will be placed vertically and the notch will be facing the direction of the hammer. If it is a Charpy impact test, the specimen would be placed horizontally and the notch would be away from the direction of the hammer. So this is the hammer that is falling. Okay, this is shown. This is where you'll take the readings of the energy loss during the transit of hammer. That readings is taken from this. Yeah, let's just see the different view of the experimental setup. So you can see this is where the hammer will rest. For ISOD impactors, the hammer will be resting at 90 degree, and for CHARP impactors, the hammer will be resting at 270 degree. That is at this point. So you can see here the hammer is resting at 90 degree. So this is the specimen that we're using. You can see there's the notch also. If it is a ISOD impactors, the notch will be facing the direction of the hammer, and for CHARP it will be away from the direction of the hammer. So this is a quick view of the virtual tour that is available for the labs that we have developed. So here there is a link to go to the simulation of this experiment. Then here there's a link for the Lagupata video of this experiment. So totally the students will get the overall experience of the lab. So there are other experiments also in the strength of material. So you can see there is compression test, Brinell hardness test, all the hardness tests, etc. So I'll just stop my session here. And hand over the session to, yeah.
Thank you, Aishwarya. We'll now close the presentation or demonstrations from the core engineering branches. So if there are any specific questions about the labs that have been demonstrated till now from the core engineering domain, specifically mechanical and civil engineering, I think we can take those questions at this point itself before we proceed to demonstrations from circuit and computer branches. So if any questions are there, I would request Chandramohan sir or any of the moderators to unmute the participants who may want to ask any questions, or they can even post the questions in the chat box as well. Are there any questions, Chandramohan sir, or anyone else?
Any questions, please? Kindly, you can post in the chat. Sir, hope they don't have any questions, sir.
Yeah, okay. Okay, thank you, ma'am.
Yes.
So if there are no further questions, we'll gradually now proceed into demonstrations from the remaining branches. So one thing we would like to request to all the faculty members who have completed attending the demonstrations is we would request you all to explore the set of resources, whatever we have demonstrated, and even the set of resources beyond whatever we have demonstrated from the particular branches, mechanical or civil engineering. And you can see what all can be used for your online classes as well as offline classes or practical sessions. And you can also use these simulations to ask the students to try it on their own. So all these are free to access resources. No other kind of registration of barriers are there, except for a few labs that may be requiring a login. That is very few in number. Okay, I think there is a question now. Will wrong experiments get repeated till we master? Okay, I assume the question you meant that whether we'll be able to repeat experiments. Yeah, any number of repetition, any number of iterations will be fine, ma'am. So any number of times you can use these resources, use the simulations. It's after all virtual tool, after all a web application. So there is no limit to the number of times you can use it or the number of people who can access it. Oh, no, there is no actual auto sensing or anything like that. So it is basically every time you repeat an experiment, it is just a different access. That's it. It's just a web platform. It's just a website, so you can access it and use it any number of times. It doesn't get counted. It does not have any login also. So after that, who's accessing it or like how many times a particular user has accessed that experiment, these things are not really counted. You can repeat it any number of times, definitely. Yes, students can repeat it manually, yes. Thank you, ma'am. I hope that question was answered clear. So if there are any more questions, we will take that at this point. Okay, there is a question about HP lab. Rohit or Aishwarya, whoever is concerned, could you please take that question in the chat box? Measuring the quantity of water collected per minute in HP lab. Okay. Aishwarya, I hope you saw that question or
Yeah, sir.
Yes.
I'm waiting for Rohit to respond.
Okay, it's from a.
Yes.
Okay, I think Rohit is not a co-host right now.
Narayanan sir, can you make?
Rohit sir is not here, sir.
I think Rohit is not in the call right now. I think we'll get him back. We'll come back to that question, sir.
Okay, sir, no issues. We
We'll
can
probably
go
come back to that question once Rohit is able to join back. So if any further questions are there, we can, for mechanical or civil branches, we'll proceed into demo circuit. I hope Srishta is there.
Yes, sir.
Yeah. So I think in that
Is my
case
voice
we can.
clear and audible?
It's clear, Srishta. So I think we can proceed into demonstrations from circuit branches right now. So over to you, Srishta.
Thank you, sir. So very good afternoon to one and all present over here.
Good afternoon,
Myself
ma'am.
Shrestha, myself Shrestha, working as Senior Research Fellow at Center for System Design, NITK Surat. So let me share my screen now. Hope my screen is also visible.
Yeah, visible,
Yes,
ma'am.
ma'am.
Please go ahead.
Yeah, thank you, sir. Yeah. Okay, fine. So now you're all familiar with this particular website of virtual labs. So as you have already seen few of the lab demonstrations from the other domains, the structure would be similar in terms for circuit related labs as well. So you'll find set of labs in the relative domains with list of experiments within each. So coming to broad areas over here, when we say circuit domain, you can see two. One is electronics and communications, and one more is electrical engineering domain. And as Beryl sir had mentioned initially, you will find labs relevant to circuit domain in the relative domains over here as well. So when we say circuit domain labs, it will be available under electronics and communication, computer science and engineering, electrical engineering, and physical sciences domain. Okay, so let us get into labs now. Before that, one more thing, you will find some of the concepts will be demonstrated under multiple labs over here. So whichever interface we feel convenient, we can pick that. And one more thing, in terms of the labs under circuit domain, if we want to roughly classify them, we can group them under three categories. One, with the very basic simulator interfaces where circuit will already been rigged up. We need to just vary the input parameters and note down the observations. That is basically for a practice purpose, understanding purpose. And second set of grouping will be, we'll have simulator interfaces such that we need to manually rig up the circuit using the components available and then proceed with the experiment. And third set of grouping will have simulator interfaces such that user need to manually get the component to workspace, rig up the circuit, provide component values of his own interest, and then proceed with the experiment. Okay, so now let's see some of the different examples for these types of groupings. So to start with, let me take you with the labs under electronics and communication domain. You will find list of labs from very basic topic to very advanced ones available over here. So to start with, I'll take you with basic electronics lab, one of the older lab from IIT Kharagpur. Okay, so the content covered with respect to each of the lab would be again similar. There will be introduction for the lab, list of experiments, instruction, system requirements will be given over here. Then technology used. If any plugins are required will be listed over here. People behind the development. So you can directly contact them if you come across any of the problem with any of the experiments within each of the lab, then will be the feedback link. Okay, so our area of interest would be on the list of experiments. So if you look over here, there are 17 experiments inside basic electronics lab. So first 3 are theoretical based, explaining R, L, and C. Rest goes with experimentation. Okay, so I'll take you with rectification experiment. I am within half-wave rectification experiment, which takes you with one of the simplest interface that is available with respect to circuit domain labs. Okay, again for each of the experiment, content covered would be similar. There will be theory explaining the complete concept. Then would be the procedure to do the experiment in this virtual lab platform. Then is the oscilloscope tutorial. So this is optional. Whichever simulator interface which involves oscilloscope or any additional components, their detailing will be provided over here in the subsections. Okay, so for example, in this particular simulation, we would require oscilloscope to observe the waveforms, input-output waveforms. So for that, simplified oscilloscope is available. So its tutorial is given over here. Then is the simulation where we actually do the experiment. Then we have set of questions to test our understanding levels, which we can answer and check. Then are the reference links. So now let us get into the simulation. For half-wave rectifier, again, we have two variations. So let me take you with the first variation, which takes us to the simplest interface. Okay. And this is how is the simulator interface available for the half-wave rectifier experiment. Here, as I already told, the circuit is fixed. Here, the brief instruction is given in the simulator interface itself. In some of the experiments, it may not be available in the simulator window. In that case, we need to open the instruction in a separate page and then proceed accordingly. Here is the simplified oscilloscope window. Below are the various oscilloscope controls. Then is the formula available, also the calculator. Okay, simplified calculator is available to do calculations. So as per the instructions, if you proceed further, we need to set the load resistance value RL using the slider. Then we need to on the experiment. Then we need to provide input by clicking on the sine wave button. Then we need to see to observe the output on the oscilloscope window. We need to click on the oscilloscope button. Okay, then we can change various oscilloscope controls and then observe the way of output variations or graph variations. So here is a slider to set the load resistance value. So one thing to note, here is a on button provided. Once you on the experiment, you'll get XY coordinates in the oscilloscope window. But once you on the experiment, you'll not be allowed to vary the RL values. Okay, so if you want to again vary RL values, we need to off the experiment, then set RL value to some other value and then proceed further. Okay, so I have taken some random value. I'll on the setup, click on the sine wave button to provide the input to the circuit. Now, if I want to observe the input waveform on the oscilloscope interface, I need to again click on the sine wave button. Then to observe the output, we need to click on the oscilloscope button provided over here. And the oscilloscope controls are similar as what we have in the actual CRO. So we can see channel 1 or channel 2 output individually. If not, we can see both the waveforms using the dual option available. We can change the Y position of each of the waveforms for better visualization. We can change the X position as well. Then we can vary the amplitude. We can vary the frequency. Here we'll be getting the peak current value. So we can calculate it manually using pen and paper and verify our results over here. Okay, here also we have direct link for the oscilloscope, virtual oscilloscope tutorial, which takes us to the same page as we had seen earlier. Okay, so this is one of the basic simulator interface available. Now let me take you to the list of labs under electronics and communication domain again, and let's see one more lab over here. So when we say circuit, one more component comes to our mind is circuit solving. Right, we have multiple laws, theorems and all explaining. So are there any labs available for that? Yes, so there are 3 labs in total available for different theorems that we study in our curriculum. So 2 labs are available over here. One is analog signals network and measurement lab from IIT Kharagpur, one more electric circuits lab from Amrita Vishwavidyapeetham, and one more is available in the new lab development portal. Okay, so let me take you with IIT Kharagpur labs over here. So the second lab, virtual electric circuits lab, what I had shown you, it was developed from Amrita Vishwavidyapeetham. And when you try to access the experiments, especially the simulators developed by Amrita Vishwavidyapeetham, it asks for a login. Okay, that is just to keep a track of how many users are using that. So you can just create your account and using the login credentials, you can keep on using the simulator whenever required. So that is the point to note with respect to the experiments developed by IIT Kanpur and Amrita Vishwavidyapeetham. All the other labs doesn't require any of the logins. Fine. So here again, with the list of experiments, these are the experiments available. So let us see one of them. So which again the simulator interface comes under first set of grouping. So again the content covered would be similar. This is the theory for this particular circuit. Complete solving has been given over here. So let us directly get into the simulator. Click here to perform the experiment. And this is how the simulator interface is available. So the circuit provided is fixed. We cannot change the circuit. But the circuit is same as what given in the theory section. Okay. Fine. So this just in a complicated way. Here is a brief procedure given to follow. Here are the different cases to go with the experiment, and below is the observation table available to note down the readings. So here you can see case 1, case 2 and case 3. Case 1 is to solve the circuit in a normal circuit solving procedure. Then case 2 and case 3 goes with Thevenin's theorem. And you can see there are two switches S1 and S2 available over here. So that is mainly to control input supply and load to the circuit. So this lab again is concentrated on practice purpose or understanding the concept. So we here with each of the experiment, we can create multiple questions. So if we have 60 students in a class, with the same experiment, we can create 60 different questions by changing each of the component values. Okay, so here case 1 is to solve the circuit normally. So I'll connect power and load to the circuit. So my S2 should be load. By clicking on the simulate button, I'll be getting the load current value. Case 2A is to find Thevenin voltage, and as per the theorem we know, to find Thevenin voltage we need to remove the load. So my S2 should be intermediate and keeping S1 in power state. If I click on the simulate button, I'll be getting the Thevenin voltage. Now is to find case 2B to find Thevenin resistance. So we know to find Thevenin resistance, we need to short the supply. So my S1 should be short and S2 should be power. Clicking on the simulate button, we'll be getting the Thevenin resistance. And now case 3 is to find the load current using Thevenin theorem. Okay, so we have VTH, we have RTH, we have load resistance connected. So by directly clicking on the simulate button, we'll be getting the load current value. Now we need to check whether the load current obtained using Thevenin's theorem and without using it, whether they are matching. So for that, we can click on fill data to the table and see the observation values given over here. So this is the load current value from the first case, and this is by using Thevenin's theorem. So both the values are matching. So basically, this is the first set of observation for these component values. So now I can change each of the component value as per our requirement, and then again proceed with the experiment to get other set of observations. Okay, so this is how the simulatory interface is available for Thevenin's theorem experiment. Similarly, the other experiments within this analog signals network and measurement lab will have the simulatory interface available. The flow would be the same. So now let me go back to the main website of virtual lab. And let us now get into the second set of grouping what I had mentioned. Before that, I'll take you with one of the lab under computer science and engineering. So if you had observed the list of labs under electronics and communication in this virtual lab platform, you would have seen many labs available for digital electronic subject or logic design subject, right? And I'll now here take you, even under computer science and engineering, there are a couple of labs available relevant to the circuit domain. So we have VLSI lab, computer architecture and organization lab also have concepts from digital electronics. We have image processing lab, wireless sensor network lab, and all relevant to the circuit domain. So here, intentionally, I'll take you with computer architecture and organization lab from IIT Kharagpur. Just with the intention, I'll get into the experiments and see here we have many experiments available. So if you look over here, experiments for flip-flops, counters, multipliers, and all are available with the labs under electronics and communication domain as well. But few of the concepts available over here is available only under this lab under computer science and engineering domain. Say for example, this cache design, CPU design, K-map, algorithm, and all are available only over here. Okay, so K-map experiment, if we just quickly look into, I'll directly get into the simulator. This operates in our cell phones as well. The simulator interface is slightly different, but it is quite simple. So here we have an option to select the number of input variables required. So if you want a 6 variable K-map, we can select that. Now there is an option to hide result. We can hide the result, take a random example by clicking on the random example button. Solve this using pen and paper, then unhide the result and check the grouping as well as the reduced expression. Okay, so we'll be getting the grouping as well as the reduced expression available over here. Also, we can reset the key map. We can again hide the result. If you want to manually enter each of the cell value, that is also possible. We can have don't care in the cells. So if you want to have one, we can just click on the cell. If you want to have don't care, we can click twice. Okay, similarly, we can fill each of the cell with that value of requirement, then proceed further in the same way and unhide the result and check the grouping and the reduce expression. Okay, so this is how the key map simulator is available. So now let's go back to the main website of virtual lab. And now let us get into the electrical engineering domain. So these were few of the labs that are common to electronics as well as electrical engineering domain. So here also there are many labs available common to all CS, IS, EC and EEE. Also there are many labs available relevant to core electrical engineering domain over here. So virtual high voltage lab, industrial electric drives lab, industrial automation lab, electrical machines lab, PLC. So there are many core electrical engineering labs also available. So when you say electrical machines lab, one of the important lab for electricals, there are 3 labs available from 3 different institutes. One is from COE Pune, one more electrical machines lab available from IIT Guwahati, and there is one more newer electrical machines lab from IIT Roorkee. Okay, so now I'll take you with the newer electrical machines lab from IIT Roorkee, and let's see one of the experiment over here. So first one is theoretical based. So let me take you with, there are 8 experiments available within this. So I'll take you with the third experiment, speed control of DC motor by field resistance control. Okay, so again the content covered would be similar. We have aim, theory. Quiz has been divided over here into pre-test and post-test. We have procedure to follow and is the simulation. So I'll get into the simulation. And this is how is the interface available. Okay, so this is an example for the second set of simulator interface what I had mentioned initially. We have components. This is just to give the hands-on experience or experiential learning this labs helps in. So this is one of the example which involves this kind of simulator interface where we need to manually connect the components and then proceed. There are many more labs with a similar flow in the simulator interface. So as an example, I can mention analog electronics lab under electronics and communication. So that particular lab experiments within that also will have simulator interface in a similar way. So here we need to connect the components manually as per the instructions given. Next step would be to check if the connections are right. Only once we have right connections being connected, we will be able to proceed further. If we have incorrect connections, we can redo the connection and then proceed further as per the instructions. Once we have right connection, we can vary the input parameters. For each of the input value, we can click on add to table and note down the values in the observation table. Once we have sufficient readings in the observation table, we can go for plotting the graph in the graph area. Then finally, we can take the printout of the entire simulation window. Okay, this is how the experimental flow will be. So as per the instructions, if we quickly do the connection A to K, A to Y and A to J. So it is A to K, A to Y and A to J. Then B to P, E to M, B to P, E to M, F to D. Then it is G to R, H to I to C. It is G to R, H to I to C, and C to H. Finally, we need to connect Q to L. So you can see node values are given in blue color. So if you want to remove any of one of the connection, we can just click on the node value. Okay, so we can just click on Q to remove this particular connection. And if we click on A, all the 3 connections connected to that particular node will go off. So if we want to remove one of the connection, we can click on the other node. So I can click on J to remove connection from A to J. So I can redo that. Fine. So once we are done with the connection, we can check if the connections are right. Yes. Now the next step as per the instruction is to on the MCB. So owning MCB, all the LEDs will turn on. Next would be to provide input value. So here we have 2 variables. One is armature resistance and one more is field resistance. So I can set voltmeter reading to some value by changing the armature resistance value. So I have kept it for some value. So since the mode is virtual for this virtual lab, there is no limitation on the boundary values. Now we can vary field resistance value in steps. So for each of the field resistance value, we can click on add to table. Okay, so you can see current and speed values being tabulated. Okay, so you can see the front view of DC motor over here. So if we take one few readings and if we click on plot graph, until we have sufficient values, we will not be able to draw the graph. So we need to have at least 6 readings. So we need to take few more values. Now we have sufficient readings. If we click on plot graph button, we will be getting the graph over here. And finally, we can click on the print option available to get the printout of the entire simulation window and keep it saved for a future references. Okay, so this is how simulatory interface or the experimental flow with respect to the second set of groupings. So now let me go back to the main website of virtual lab. And other than these labs, there are many more labs available relevant to circuit domain in the new lab development site as well. So let us look into one or two from there. So under explore labs, as you had seen in other demonstrations, we have 2 variations, approved labs and labs under development. So I'd like to take you with one of the lab under labs under development section. So let me take you with integrated circuits lab. This is available in the labs under development section.
Ma'am, just the question. Do you have laboratory for power system, madam? Power system analysis, power system operation?
Yes, sir. Actually, there are many more labs available. So today we had shown only few of the demonstrations.
Okay.
So yeah, as I had mentioned initially, so those labs are available either under electrical engineering domain, also under new lab development site. So you can explore the labs available in both the places, sir. Okay, so here we were inside integrated circuits analysis lab. So we have 6 experiments currently within this. Let me take one of them. In the simulation section, so if we look into the interface, this is an example for the third set of grouping, what I had mentioned initially. Okay, here we have the workspace. We can get the components from here, get it to the workspace, set component value as per our own requirement. Then once we have all the components in the workspace, we can do the connections. Using the connect option available, we can get the op-amp to the workspace. Then we can select the input type as per our requirement. 3 variations are available. Okay. So once we have all the components, we can connect each of the component using the connect option. Before that, if you want to move any of the component, we can use the move option available. Click on any of the component and place it as per our requirement. And we can connect each of the component using connect option available. We need to click on the node points. So if we can undo the connection if anything goes wrong, we can clear all the entire work area and then redo the connections. So we are done with the circuit. Now we can get CRO to the workspace. To check the input output forms, we can connect input and output to the CRO before proceeding with the experiment. We can connect input and output to CRO. Okay, now we can on the simulation. So if we have all the connections connected right, all the wires will turn into green color. Okay, so we can on the setup. Now we can click on the show graph button to observe the input output waveforms. Also, we can get the frequency response of the circuit by clicking on the frequency response button. So this is how the third set of grouping simulatory interface flow will be. Okay, so also as I told, there are many more labs available under approved lab section as well. So example, microcontroller lab and other labs relevant to the circuit domain are also available over here. Okay, so microcontroller lab, here you'll be having a small editor where you can write your own code. So I'll be taking one of the example. This is developed by one of the nodal centers. So if you look into the simulator interface, here you'll be having a small editor where we can write our own code. If not, we can copy the sample code and proceed with the execution. So I'll copy the sample code now for the 7-segment display. The experiment is mainly to interface 8051 microcontroller with the display devices. So here we have pasted the code. We can go for one-time execution using the run option. If not, we can go for the step-by-step execution using the debug option available. We can see the output over here. We can change the port selection as per the code requirement. We can see the memory mapping over here. We can see the pin mapping over here. Here also, we can take the printout of the entire simulation window and keep it for a future references. Okay, and below we have set of questions which we can answer and test our understanding levels. So we have currently 3 experiments within this particular lab, and many more will be added in a future time. Okay, so these are few of the examples with the simulator interface of the labs under circuit domain. So we have many more labs available, which we request you to explore and come up with the queries if any. So with this, I'll stop sharing my screen and stop the presentation from my end and hand over the session to my colleague Beryl sir. Over to you, sir. Thank you.
Thank you, Suresh. Thank you for the demonstration. So I will be now going through a few labs in computer science and engineering. And before going into that, there was a question from Chandra Mohan sir regarding virtual tool prerequisites. So prerequisites are, I've mentioned it in the chat box itself. So specific to each lab, I'll be sharing my screen as well in between. So specific to labs, specific to each one of the labs that are there on the VLAB platform, there may be some requirements. There may be some dependencies or requirements specific to each one of the labs that are there. So that will be mentioned along with in the lab, respective labs itself. So in almost all the labs, whichever lab you go to, you will be having some set of menu items like requirements or instructions. Within that, you'll be having the dependencies that will be there for running that particular lab. And one thing is that most of the labs that have been recently developed and deployed will be running simply without any complicated dependencies on your browser itself. So whether that is mobile browser, mobile-based or Android or iOS-based browser, or PC-based browser on your Linux or Windows or Apple machines, you'll be able to run it seamlessly on your web browsers. So specific to some of the labs, rather a few of the labs, there may be some additional dependencies which will be mentioned along with the labs itself as part of the instructions to the lab itself. And one specific issue will be with regard to Flash. So Flash, there were quite a few labs, as it was mentioned earlier. VLab has been around for more than 10 years now, even though it has garnered a specific or an added level of interest due to the pandemic during this recent period. It has been around for many years now. And during 2010s or 2000, like the earlier part of this decade, you may all be knowing that for animated images, for animations and everything, Flash was the most popular technology in use. So at that point of time, most of the labs that were created were based on Flash. And due to that reason, many of the labs that were created at that point of time are still around. And what the consortium of participating institutes is doing is that all those labs are being replaced by HTML5 based labs that will run seamlessly on your browsers right now. So almost 70 to 80% of labs that were on Flash earlier have been migrated over to HTML5 right now, but there are still a few labs left to be upgraded to or updated to present day browser technology, that is HTML5 and JavaScript based labs. So for running those labs, in case those subjects are inevitable to you, the subjects that are there available in Flash and yet to be replaced by HTML5 versions, if you have to run it, you have workaround that is mentioned here on the VLab homepage itself, along with announcements. There is a link. Please click here to download VirtualBox. That link is actually taking you to a Google Doc that has a set of instructions on running labs that are based on obsolete technologies. So as you may be knowing, Flash will not run anymore on any of the browsers, any of the currently available browsers. So you'll have to configure something that will take your system to a previous date. So this actually provides a link to an 2014 edition Ubuntu 14.04 version that is configured with the necessary plugins to run the outdated labs is available for download. The link is available on this document. Image, setting that OS image on your computer using VirtualBox. So VirtualBox, many of you may be already familiar with VirtualBox for emulating a different operating system in the OS that you are using. So you'll have to Ubuntu 14.04 edition the necessary plugins on VirtualBox, and with that you'll be able to use labs that were based on Flash. So that instruction set is available here on this document that is linked as part of the announcements here. So this has been a recent development, as you know that Flash has reached end of life a couple of months back. So as part of that development, this alternative workaround was created by the consortium. So I hope that part was clear. Thank you, sir. So thank you for raising that question. So if that is aspect also, we can raise it over the chat itself. As I'll be proceeding over to my topic of discussion, that is labs in computer science and engineering. So I think I'll turn off my cam also to save the bandwidth. So I hope I'm clearly audible. No, sir. Chandramohan sir or anyone else? If I can get a feedback. Yeah. Yeah, thank you, Srishta. So, computer science or virtual labs in computer science is a sort of paradoxical situation. Going into virtual labs, this interface is already familiar to you. It has been familiar demonstrations in power and circuit engineering branches. So, you will obviously be knowing that you have to click this link and you'll be taken to the list of labs available in computer science. So in computer science, as you may feel, it is a paradoxical situation because most of the labs labs in computer science, that is programming based labs specifically, not the hardware based labs, which has orientation towards electronics and communication more. Most of the programming based labs are, after all, virtual itself. You don't require any additional apparatus or circuit or machine like we require for electrical or electronics or mechanical civil engineering branches. You'll require a computer with the necessary kind of softwares or IDEs or compilers, whatever that is required to run those programs or to compile those programs. Will have to be installed on your computer, and that's it. So what is there in virtual labs for computer science learners as well as teachers? Obviously, creating this resource was an effort, that a transdisciplinary effort that was done by both programmers. So in that way, programmers will have a role in creating and running this platform. So obviously, I feel many of the faculty members from computer science who might be interested to work on this development front, you can have a look at the new lab development page and the tutorials on it. I had mentioned it at the beginning. And even developing a lab in any area, it will require the efforts from people of expertise in that domain as well as coders as well. So if you want to develop a mechanical engineering lab, you'll obviously need subject experts from mechanical engineering, and you'll require them to be supported by programmers from computer science domain as well. So overall, it's a transdisciplinary activity, and that should also be of interest to people from computer science background. And coming to the programming part of it, programming learning part of virtual labs. So what virtual labs in computer science generally tries to do is, it is trying to give the learners a better cognitive understanding the subject, rather than just simply emulating what can be otherwise done on an IDE or a software that is installed on your computer. And even installing and configuring the necessary resources or necessary program software for running some experiments can be tedious at times. So that can be avoided if you have a virtual web accessible solution. That is one advantage. And the second most important thing is that virtual labs tries to consolidate or integrate all the theoretical and practical aspects of the programming subjects at one place. So the cognitive understanding or the subject specific understanding for each one of the programming subjects is what virtual labs is trying to do. And there are even a few labs that are completely theoretical, so completely algorithm based labs where the simulations are trying to train you on how to understand or how to get a good grip of that algorithm based subject or whatever it is. They are completely theoretical and detached from the language or programming platform part of that experiment. So much different, much variety is there in labs developed in computer science. So as you can see, many of the labs here are developed by IIT Hyderabad, and there are even a few labs contributed by IITs Delhi, Kharagpur, etc. So that is the kind of offering that is available in the computer science domain, and there are even a few labs that are available under the labs under development section also. So here, as we had seen before, it is not segregated according to department, but there are several labs in computer science available here as well. And even you'll find some of the labs are getting replacement. So computer graphics, for example, is available here. It's available here also, but the older version was Flash based, and the HTML5 based replacement available here with the new lab development portal. And data structures was also initially a Flash based lab, and now the updated HTML5 version is available here as 2 parts. So this is how the general structure of labs is there in computer science. And now coming into the labs. So as I've already mentioned, the running of programs, executing programs on your machine, on your offline installed software, it's the easiest thing to do for computer science subjects. But if you have a resource, have a place where you have theoretical material also, it will be of greater advantage. So basics of HTML, I'll go into this lab first. So I'm using this upcoming labs more because these are recently published labs with which were developed in HTML5, and they'll have a better interface in comparison with the older labs. So if I go to HTML5 HTML lab, you find this interface, which you have already seen for many other labs demonstrated in circuit and core engineering, adopted by the consortium for all the recently developed labs. So you have the theoretical material and you have a link for list of experiments, which will take you to the list of experiments. We have 10 experiments here in the list, and I'll go to the first one, the basic one. And going into this, as you could see, there was theoretical material available and specific to the lab also. You have this particular page with all the common headings that we would otherwise present in our record book also, aim, theory, procedure. So you can go through all the theoretical material specific to the experiment. You can have a which is an MCQ before going into the simulation. Then you have the instructions to use the simulator, and as already mentioned, the instructions, wherever you have it, it will be the instruction to use the simulations. And further, you can proceed to the simulation. So in the simulation, what we have here is, along with the theoretical materials that were there in the previous headings, previous chapters, you have the necessary instructions to use this simulator. So here in this particular simulator, we have a text box, a code writing box, where you can write your code and see in the preview box what the output will be. So you have all the options like configuring a header, tags, configuring paragraph tags, bold tags, italics, all the basic things are available here. So how you're supposed to do all of these and what result it will show, you can get a preview here as well. So you will, otherwise you will be doing this with the help of an IDE or with the help of Notepad++, whichever tool that you will be using on your system. So you have all this at one place, all the theory plus all the practice tools at one place. In this case, that's the advantage with virtual labs for programming subjects. And even if you go to the other experiments in HTML, you will find a similar kind of structure. You have all the theoretical material pertaining to each kind of tags, and you will have practice place workspaces where you can write your tool, write your code, and see how it runs. And many of the other labs in the computer science offering, like core Java, Python, and even under the new labs, you have PHP, then networking labs. All these labs have a similar kind of a structure where you have workspaces where you can write your code and execute it, see it getting executed along with the theoretical material also. And there is even an older version of this kind of a lab in problem solving lab, which is actually for C and CPP subjects. So this is an older lab, so it's having a little bit of support issues right now, but still you'll be able to run many of these experiments for writing and running code or programming programs on C language alongside theoretical material on that as well. So this is one kind of type of experiment in computer science. So where you have theoretical material plus workspaces to write your code and execute it and see how it is working. So that's one kind of lab. And now I think I'll go into a second type of lab, which is a slightly older model. So it's called computer programming lab. So computer programming lab, again, it's developed by IIITH. And the interface is a little bit old school because, as I told, it's one of the earlier labs in computer science. So this is a general lab for that explains the common programming practices or programming constructs that we follow across all platforms, in fact, not just in C or CPP. Even though this particular lab uses C as a backdrop, it has 9 experiments that explains basic programming concepts with the help of C language. So if I click one of these experiments, it will take me to the experiment page. Yeah, it will take me to the experiment page. Again, the even though the look and feel is slightly different, you have the similar kind of headings in the form of aim, introduction, theory, objective, then the procedure. So the procedure, again, it's a procedure to run the simulation. and further reading materials as well. And you have a quiz also, and you have the simulation as well. So the simulation has two subdivisions, matrices as well as two-dimensional arrays. I'll go into one-dimensional array right now. So you should have looked at the procedure and come here. So since I have the procedure understood right now, I am supposed to initialize this simulator. So here what I did is I have given a input test condition and I have a C code over here. A C code that is written with the insertion sort algorithm. So this is default for this particular experiment. So this experiment in arrays, what it is trying to do is it is trying to explain the concept of arrays with the help of a particular randomly chosen algorithm which is written or presented in C language. So I have a next button over here, and what this next button does is it will execute this code line by line. So line by line, when this code is getting executed, you will get to see how the input is changing. So input, this is the input over here right now, the randomly set input. You have the option to enter your own custom array also. So you can try various things like best case, worst case, even here as well. So when you run this program, so those who know the algorithm will understand that you have a nested loop structure. The outer loop will increment, set a key position value at a of 1 and go up till a of n minus 1. And the inner loop will be comparing the key position value to all the elements with all the elements to its left and positioning itself. So what will happen in the first iteration? The while loop will execute, and at the end of it, 9 and 1 will get swapped because they were unsorted. And there will be no further iteration of the while loop because there are no further elements to the left. And it will go to the for outer loop test condition again, and it will get key position will get incremented. So likewise, the entire execution of the code can be step by step, line by line, iteration by iteration of the code. So in the next iteration, nothing will happen because the previous element also was 9. A of 1 and A of 2 are both having the same value of 9. So nothing will happen. The loop will exit and the key will get incremented to A of 3 where the value is 10. Again, it will skip the inner loop because it is in sorted condition. And in the next iteration, what will happen is key value is being 0, being the lowest element in the rest of the numbers, among the rest of the numbers. It will iterate the loop 1, 2, 3, 4 times to position that value 0 to A of 0 position. And then even the for loop will exit because the array has reached the end of array. The key position had reached the end of array, and you'll get a message that the code execution is over. So you were able to see how the input is getting transformed to the output line by line with the execution of the code. So this is the way in which all the other labs in computer programming are also, sorry. So even the other labs in computer programming are structured in a similar way. It has a C code, it has a default C code, and you have customizable input conditions, and you can run that code in this way, line by line, and see how the process is ongoing, which is actually not possible with the normal offline IDE that we will be using. That's the advantage of using virtual labs for computer science. You can follow things more closely. You can use the simulations to understand the algorithms, understand the concepts better. So this is one more different kind of lab in computer science. Then there are labs that are completely theoretical. So if you take the example of data structures lab, so it is one example of labs that are completely theoretical in nature. So if I go to data structures lab, as I told, data structures had an older version which was flash based. This was also completely theoretical, and it is now getting replaced by data structures new lab in 2 parts. Together it has around 15 algorithms discussed. So if I go into one of these labs, the interface is similar again, since it's a newly developed lab, and you have the list of experiments in part 1. So you have all these experiments. So if you go into one of them, the interface is again similar, and the headings are also further similar. You have aim, overview. So here one more advantage is that even it's theoretical, and it uses video tutorials to support the learning. So you have video tutorials alongside concept notes, and also visualizations, which is helping you to demonstrate or explain each one of these algorithms. So I did almost 15 algorithms in data structures lab, 15 experiments in data structures lab. And going into specifics of the two algorithms, so you have in bubble sort as well as optimized bubble sort algorithms discussed. So we further have another aim section, then the concept explained with the help of tutorials, which you can play and see how bubble sort will work for a particular case. You have the algorithm here written in plain English language. As I mentioned before, this is complete. This is a completely theoretical lab, and does not link itself to any particular programming subject. You can learn the algorithm, you can practice or play around with the algorithm, and then implement it to any programming language of your knowledge or convenience. Demonstration also comes with visualizations as well as video tutorials. And then we have 3 simulations actually in this. So you have a demo. The procedure or instructions is given along with the simulation itself. So here in the first simulation, it's a completely automatic random array over here. So you can see how bubble sort will work. You can see the observations, how comparisons, how happens in each stage. So it is getting swapped when the elements are, or the first element is likewise, how bubble sort algorithm will work on this particular condition is what is demonstrated in the demo part. And in the second simulation, so it will carry on until the entire array is completely sorted. So which is probably going to take a little more time. So I'll skip over to the next type of simulation. So in the second type of simulation, that is practice, you have the instructions. So the instructions actually ask you to implement manually. So earlier we saw the simulator running by itself. So here you as the user or you as the learner is supposed to run bubble sort on this particular set of numbers. So here I'm supposed to swap the 2 elements. So you have swap and next buttons. So I'm supposed to swap if the elements are unsorted, and use next if the elements are sorted. So here I'm supposed to swap. So here again I'm supposed to swap, but if I make a mistake, I'll get a message that I have been wrong and I'll be asked to correct. Again, I'm supposed to swap, and if I try to swap in a condition when I'm not supposed to, likewise, I'll get. So like in this pattern, you can continue implementing the bubble sort algorithm until the end of this process. And now set of particular array. So this is how bubble sort is practiced. And in the third level, that is exercise, it's a slightly more complicated way, or a slightly more advanced version. So you're supposed to start running the algorithm, and you're supposed to swap when you need to swap and click next when you need to click next. That is, the iterations only are happening. So you'll get to see the number of out loop iterations over here. And here again, I'm supposed to swap. Again, I'm supposed to swap. Again, I'm supposed to swap. So here one difference is that if I make a mistake, it will not correct me. I'll get to know that when I submit the answers. So at this point, if I try to submit, it'll tell me that I am completely making a mistake. So even if I make a mistake in between, like swapping when I'm not supposed to, or not swapping when I'm supposed to, if I make such mistakes, it will not correct me. At the end only, you'll be getting to see that we have not completed it. You have not implemented bubble sort in the correct way. So that's how the 3 levels of simulation is used in the data structures lab. You have a completely automated one where you can see, and then you have a place where you can practice, and then you have a completely advanced level exercise where you're supposed to run the algorithm. So using these 3 simulations, you can get a good understanding of the algorithm. So you had the tutorials, the videos and visualizations that taught you how the particular algorithm is working, and then you are asked to practice or exercise that algorithm on a given set of numbers. And you have all the instructions as well. The optimized bubble sort algorithm is also structured in a similar fashion. And then you have a chapter for analysis. In all the data structures labs, you have an analysis chapter also, where you have a discussion specific to time and space complexity. Again, this also uses notes as well as video tutorials. And you have some stability discussions also. Again, visualizations, demonstrations, simulations are all there to explain the complexity part of it, and also comparison in terms of time and space complexity with the other sorting algorithms. So likewise, there is a chapter for algorithm analysis as well. Within so this is a general structure for all the experiments in data structures. So if you go to any of these experiments, you'll find a similar kind of structure. You will have video tutorials, you'll have simulators that will aid you to practice that algorithm on a given input conditions, and you will have algorithm analysis lessons on time and space complexity as well. So this is one example of labs that are completely theoretical, as I told, which does not link itself to any of the programming languages. And likewise, cryptography, computer graphics, and several other labs. Computer graphics, as I told, the one version here is not working since it is flash based. You will have to use the version that is available here, along with approved labs and labs under development, which is actually having a computer graphics lab here. So here also we have 8 experiments in computer graphics lab, and inside the structure is again similar. If you go to into one of the algorithms, you have a similar structure, and within the algorithm, you are supposed to, you'll have a question, you'll have multiple questions in fact, and you're supposed to use this canvas to draw draw lines or implement on this canvas. So similar to what we saw in data structures. So it's completely theoretical. It is not using any language as such. You're asked to practice the algorithm with the simulator. So these were examples of labs that are completely theoretical. And then there are even other labs which has a mix of all these. You have labs in networking. So there is an advanced networking lab that is listed alongside electronics and communication. So in fact, for many subjects, you may have to look at lists of experiments in other areas also. So networking, many of the useful labs for computer science faculty is available with under electronics and communication. So likewise, you can explore yourself all the labs and resources that is there in specific to your subject areas, specific to topics handling or the topics you may be researching upon, and you can make use of all the resources that is available. And I'll stop my presentation now. So you can have a look at all the labs that are available on the platform, and see which all of them are used for your classes, your classroom activity as well as your research activity, and make the best use of it. You can advise students also to make use of these resources. Even students may find one lab interesting or over the other, or they may find better resources than what as faculty may be suggesting. So please kindly familiarize all these resources to your students and train on how to make use of this, how to identify and make the best use of all these resources that is there. And even as Gangadharan sir has had mentioned during his introduction, contributions to this canvas, this catalog of resources is also something that is expected from deemed to be university institutions like SRMIST. So with this, I will conclude my presentation part, and we will further wait for some more questions from the participants, faculty members. If any questions are there, it can be raised at this point. So I think there is one question from Gauri ma'am. Are you specific programming language was the question. I'm not sure what it was, whether it was about the labs or whether it is about development. If you could clarify it, ma'am. Okay, data structure or DDA. So if it's about the lab, there's no tie-up with any programming language, ma'am. So data structures, graphics, cryptography, most of these labs, in fact, all of these labs are language neutral. There is no programming language that it is directly associated with. It is completely, you can practice algorithm, learn the algorithm of the theory, and you can practice the algorithm using the simulators. And you can obviously, once you are familiar with the algorithm, you can run it on using like write code with any programming language on your comfortable ID, even outside on your offline compilers like you do it for normal. So there is one more question about conduction of examination dynamics there. Okay, that's about conduction of examinations. I think KVG sir is also here. Sir, would you like to take that question about examinations?
Now, presently, ministry has not looked at the requirement of conducting the examination. What we did is, we have asked the students to run, because every time when you conduct an exam, you get a different parameter. So we asked them to record it, screen record it, and then make a PDF also and report it. That is what we did for our examination, our labs. Whereas in due time, I'm sure that they will also come up with an examination like what IIT Madras have done for NPTEL. So we are hoping that it will happen within short span, but still things are getting delayed. So once it happens, we will have one exam module, that is student can log in and conduct the exam and get it. Presently, it is not exam oriented. It is more to do with, it will be the faculty who decides how to conduct the exam on that as of now.
Yeah, thank you, sir. So, there are any further questions from the participants? Can over the chat box, or if the host permits, over the microphone as well.
And before that, to add on to the question on Power Systems Lab that had come during the circuit domain presentation, other than the labs available in the virtual lab platform, one more lab from the Nodal Center of NITK Surathkal, SRM other campus, PALS partner institute. That particular SRM institute is developing a lab on power system simulation. So that will be coming up shortly.
Thank you, ma'am. Thank you.
Yes, sir.
Any other questions, please?
Yeah, Dr. Gauri has asked, is there a tool or analysis for student understanding? What we did was, we did a pre-quiz. There is a 10 question or 5 questions of similar toughness is given. Then at the end, again, there is a post quiz. And the student can understand what is the delta X. Whereas there was a suggestion to make sure that it is also documented. As of now, it is not done. But it is more a self-assessment for a student or a learner to understand what is the delta X the person got after doing the experiment. So that is the advantage of pre-quiz as well as post-quiz. Yeah, I think Dr. Ramya, it will be better to wind up because we have been holding them from 10:30 onwards.
Okay, sir.
And they have energy to further continue. And this is an online activity.
Okay, sir. Thank you so much, sir. I thank Dr. K.V. Gangadharan, sir, and the team for the wonderful session, sir. Thank you so much. Now, may I invite Dr. J. Jagadishan, sir, Vice Principal, Admin, to propose the vote of thanks.
Thank you, madam.
Thank you.
I'm audible, madam?
Yes, sir. Yes, sir. Yes, sir.
Yes, most respected chief guest, Dr. K.V. Gangadharan, respected director, respected dean, beloved vice principal, academics, heads of the department, faculty members. Good afternoon, one and all. It's my privilege to have been asked to propose the vote of thanks on this occasion. On behalf of SRM IST, a big thank you to Dr. K.V. Gangadharan, Professor and Head, Center for System Design, for his excellent speech regarding the virtual lab. My sincere thanks to Director and Dean ENT for their valuable speech on this occasion. I extend my thanks and appreciation to Vice Principal Academic Dr. Prabhakaran for his effort to establish this Virtual Lab Nodal Center in Ramapuram campus. I strongly believe this Virtual Lab Nodal Center would cater the needs of our students and also the research scholars. So finally, I would like to thank all for making this event a success. Thank you.
Thank you, sir. Thank you, one and all. Thank you, everyone, for joining the session and making a grand success. Thank you, one and all. Thank you.